morning, everyone. On behalf of the ISO, I'd like to welcome you to today's Resource Adequacy Modeling and Program Design call to discuss modeling improvements and straw proposal leanings and options. My name is Christina Guimera, representing ISO Stakeholder Affairs, and I will be facilitating today's meeting. Today's slide deck presentation is available on the initiative webpage, and you can get to that page by going to kaiso.com and then under the Stakeholder Center tab. On the home page, you'll see policy initiatives. If you click that link, it'll take you to our main initiative landing page, where you can then search for the initiative webpage. This meeting is being recorded, and the video file will be posted to the initiative webpage for information and convenience purposes only. The recordings and any related transcriptions should not be reprinted without the ISO's permission. If you need any technical assistance at any point during the meeting, please send a chat to Inteller Events, the host. To ask questions during the meeting, you can open the participant and chat panels on the bottom right. You can then raise your hand by selecting the raise hand icon, or if you joined audio only, please press *3 on your device. For everyone joining us today, please state your name and affiliation first before speaking. You may also send comments and questions you have via chat to all panelists. This is a visual representation of where we are in the stakeholder process. As you can see here, we're in the proposal development stage right around the straw proposal. Today's agenda will begin with Aditya giving some welcome remarks, followed by Ansel reviewing stakeholder feedback. Then Shuping will take us through 2024 showings Backcast analysis requests. Then we'll take a brief break before launching into modeling improvements with Sai. And then Mark will discuss default counting rules proposal options. Then we'll have our lunch break before delving into accounting for Ambient, Derates, and UCAP with Ansel. Then we'll take a final break before our final presentations by CISA and LSCs before we adjourn for the day. And here's the preview of what we'll be discussing tomorrow for tracks 2 and 3. This is also on the initiative webpage if you'd like to review it before tomorrow. So with that, I'll turn it over to Aditya to get us started.
Thank you. Welcome, everyone. As you all know, the RA program design has been working on in three parallel tracks at the same time. We'll focus on modeling and defaults today, a little bit on UCAP and ambient derate discussions. The other two tracks in substitution and visibility will be the focus of tomorrow. I will pass here quickly to Ansel for a recap, and then I'll come back.
Yeah, thank you, Aditya. So Ansel Lundberg here, excited to take another look at where we are in the development of the straw proposal for these three tracks coming in the next few months. This morning we will have some modeling updates, as Aditya mentioned, and I think we'll have a little bit more on the details of the schedule for the next couple months and what the plan is for deliverables and the straw proposal development tomorrow. So we can touch on questions. We do have a timeline here on the slide, a proposed schedule, which has been shown in other KAISO venues in the context of other policy initiatives that we're working on. So this is the elements of the RA modeling and program design initiative. You'll see track 3 is broken out into two sort of parallel timelines. And you'll hear more about that from Hillary tomorrow. So this is kind of, like I said, our initial outlook as where we stand today. This is, I would say, tentative based on kind of the input that we get from stakeholders and how much time we need to develop and flesh out the proposals. So this will be updated as we continue to meet throughout this year as we develop the straw proposals. So that's all I have on the schedule for right now. I'm going to hand it back to Aditya.
Noah Tom from Middleware Power. Noticing sort of there's no implementation schedule for track 2 and track 3A. I assume in your Excel spreadsheet that potentially it goes beyond the Q4 here. But is that still true, or is that a true assumption?
That is correct. That is
Okay.
correct. Partha, did you want to add
Sure.
anything? Yeah.
Yeah, I think it's probably more just an acknowledgement that there's probably too much uncertainty to provide a scheduled path for implementation this time. We recognize that there's probably, we've received a lot of feedback. We're trying to move the ball forward tomorrow. Bonnie's going to be discussing some of the options that we're considering, but yeah, we didn't feel like it was appropriate to have like an implementation date on those items.
Thanks, Bertha. With regards to the policy development of backstop reform, I personally think that it's very linked to track one, and so I would sort of, RA as a whole framework is all embed, is all a little bit of a mess together. So I don't think we should implement them in a tier process, mainly because of how operational it ends up being, and therefore it would be beneficial, I think, here to think about some of the policy issues and certainly the implementation, so that they're implemented together and not stair-step. Thanks.
I noted your comment, Noah. Thank you.
All right, thanks. This is another little bit more on the agenda that we will discuss the first thing in the morning today. Thank you for all the stakeholder feedback that we received for our November 19th workshop. There was a discussion on the 2024 RA showings backcast analysis. We have a few slides here talking about that request in particular. Then there was a lot of discussion on model inputs and modeling methodology improvements requested in Plexus. We have done a lot of test runs over the last couple of months, model data pulling and updating everything to the new version of Plexus. And there was discussion on modeling hydro stochastically instead of using an average hydro year. Battery modeling improvements were requested, and updated outage rates. So we'll have detailed discussions on all of those in the morning also. The next phase is in the default counting rules and default PRM discussion. We would like to bring forth a set of proposals that we've heard through stakeholder conversations and comments provided. There are 4 proposals in total at the high level. Obviously, these are not even draft level. These are high level discussion items, and we will get additional feedback on those in this round of feedback. And then we'll talk about next steps and give you a glimpse of the timeline and what to expect from a modeling standpoint. So before we get into the details in more detail, I'd like Ansel to come and discuss our stakeholder feedback and KAISO responses. Thanks, Ansel.
All right. Thanks again, Aditya. Let's see if I can get this. Okay. So we got a great set of informative and constructive comments from our stakeholders at the November workshops that we held after the issue paper was released and the last round of modeling updates. So thank you, everyone, for your contributions to our comments. We also met in December to talk a little bit about process and about kind of the direction for the beginning of this year. So that was a helpful conversation as well. So this is a focus on the comments on the modeling efforts as well as the default counting rules and PRM. So I'll just walk through these a little bit and share a response. Many of these will be addressing in more detail later this morning. So the first comment here, there were many parties that were supportive of our efforts to perform 1 in 10 loss of load expectation modeling to update our default rules in our tariff, particularly in light of new state legislation, Assembly Bill 2368. So just acknowledging that, we appreciate the engagement and input as we develop the models and refine inputs and assumptions to update the default rules. We also heard from stakeholders. Several parties mentioned continuing to work with the CPUC to align or clarify some differences between our loss of load modeling efforts. So we understand that, and we continue to work with state agencies such as the CPUC to better understand some of the differences in our models and align them as appropriate. And there was a suggestion of a shared data set. So I think we'll be speaking a little bit more to that, but we understand stakeholders' desire to be aligned in our modeling efforts. So there were other suggestions from stakeholders, several stakeholders, and we discussed in November the Backcast approach. And as Aditya mentioned, we'll be discussing a little bit of work that we did on that after this. So maybe I'll run through these comments. We just have a few more slides of comments, and then we can kind of pause, and if there are any clarifications that folks would like to make, we can do that. Several parties mentioned a goal of a set of unified counting rules across the CAISO BA. You know, we continue to remind folks that local regulatory authorities retain control over their own RA programs, as has been the case. And the scope of work for us is just updating the default qualifying capacity methodology and PRM in our tariff at CAISO. And these should only apply to LRAs that don't have their own QC and PRM methods. We also, there was a great comment from RM about clarifying our intent when considering marginal ELCC methods, which would be a significant departure from our current counting rules, as indicated in the comment. We are looking at marginal ELCCs, but again, I just want to go back to that previous response that these are, the intent is to update the default rules in the tariff, and LRAs continue to retain their design over their RA programs. And CalCCA had a comment related to the default counting rules in support of placing all resources on a level playing field and accurately reflecting their capabilities. And that is the direction we are moving in, and so you'll hear more detail about that approach when Mark reviews the counting rule options. A few more on counting rules here. So there were sort of a mix of comments from different parties supporting different counting rule approaches, accreditation methodologies, and we're just acknowledging those differing opinions and motivations. So thank you for weighing in. That's helpful for our process. I did want to note that non-CPUC local regulatory authorities did not suggest explicitly adopting slice of day for our default counting rules. We also heard some thoughtful input about kind of our processes accommodating slice of day at the CPUC. So we continue to look out for that and make sure that we can smoothly integrate that into CAISO's RA systems. And there was a comment about sort of commenting on slice of day alignment with our processes and the benefits and drawbacks that holds. And like I said, we are continuing to analyze slice of day's impact on our procedures. So this year is the first year of implementation for slice of day in 2025 showings. So we are keenly watching out as all of our participants for what that means for our systems. A few comments on the default planning reserve margin. CalCCA and SoCal Edison mentioned alignment between the planning reserve margin and the counting rules, accreditation methodologies. We're supportive of that holistic approach in our default rules. And we had asked about the frequency of updating our default rules and planning reserve margin. And so a few parties weighed in on that in support of updating our values on the same cadence as the CPUC is going to look to update theirs. And 6 cities shared their interest in a seasonal planning reserve margin for both gross and net peak needs. We thank you for that input. That's very helpful. the schedule for updating those default rules is to be determined. I think we're going to continue to discuss that once we get closer to perhaps a final proposal for updating the default rules. So those are all the comments on the counting rules and PRM. There are a few helpful, and there's significant constructive input on the modeling updates, which we've discussed over a few meetings last year. CISA requested a formalized kind of final inputs and assumptions document from what we had shared in October. So we are continuing to develop that document based on the changes that we made to the model. Several parties mentioned updated forced outage data inputs. We'll be discussing that today, as well as incorporating the latest IPER forecast. So we will be incorporating that to make sure that we have the latest inputs for load forecast. Microsoft and WPTF commented in the written comments on updated storage modeling and dispatch. There will be more about that with the Plexus update today as well from SCI. So, and there was a mix of comments on kind of different resource profiles and assumptions to make sure we are capturing the sort of performance and behavior of different stochastic variables, such as variable energy resources, retirements, and hydroelectric modeling, like Aditya mentioned. So we're continuing to refine. Again, you'll hear kind of the latest on our outage data and some of these other inputs and assumptions in the model. So that is the end of kind of the comment review. Again, we appreciate stakeholders' constructive feedback as we work through the modeling efforts and continue to update and refine our inputs and assumptions. I think we will appreciate discussion this morning about the modeling and the work that we continue to do. So if you have additional comments, we'd love to receive those today or in the written comments after this meeting. So we can take a moment now to check in if there are any clarifications to what we just shared. I think a lot of them are, like I said, to be addressed later this morning in more detail. So would anyone like to comment on any of the feedback that we shared today or clarify anything? And Christina, I'll look to you for hands on the phone. So
I'm not currently seeing any questions online.
All right. Great. Well, thank you for letting me run through that and just check back in where we are with the comments that the stakeholders shared. So with that, I will hand it to Shuping to review our Backcast analysis that has been discussed in previous meetings and give the latest.
Thank you, Ansel. As Ansel mentioned, during the November workshop, stakeholders requested an LOLE analysis of the 2024 RE issuing portfolio, also called the Backcast analysis. We had multiple discussions on this topic. Given the resource-intensive nature of an LOLE analysis, CAISO staff conducted a high-level analysis to provide additional information. I will walk you through the results of this high-level analysis and provide an opportunity to discuss it today. The 2024 Scenario 2 portfolio was developed using the load-serving entity survey. The survey showing portfolio is adjusted based on historical RE showing data. Scenario 2 modeled RE capacity in excess of monthly obligations and is consistent with historical pattern of observed excess. Instead of conducting a detailed LOLE analysis, CAISO staff compared the 2024 RE showings to the 2025 Scenario 2 portfolio that was modeled in Plexus for previous workshop. Additional differences CAISO staff examined include the updated IPER load forecast and new resources coming online since 2024. Solar, wind, and hydro resources shown are compared using nameplate capacity, which is consistent with how those resources are modeled in Plexus. Other resources are compared at shown capacity. This chart shows a comparison of the 2025 Scenario 2 and 2024 showing portfolios. As you can see, the monthly portfolios in Scenario 2 exceed 2024 showing portfolio, except in May. Although the total supply capacity in May 2025 is lower than the total supply capacity in 2024 showing, the IPER load forecast for 2025 is also lower than the forecast for 2024. Therefore, overall, the supply condition actually improves in 2025 for all months. This chart provides a closer look at the differences between the 2025 Scenario 2 and the 2024 showing portfolios. As I mentioned before, in May, even though the total supply capacity in 2025 is lower than the total capacity in 2024 showing, but because of the load forecast, IPER load forecast for 2025 is also lower than the load forecast for 2024. So overall, the supply condition in all months in 2025 improves compared to 2024. This table summarizes the LOLE results for the 2025 Scenario 2 that we presented in previous workshop. So for 2025 Scenario 2, the LOLE result is 0.308. This does not meet the 0.1 standard. Because of the improvement in the total supply capacity condition in 2025, staff expect that the 2024 shown RE portfolio is not expected to produce a lower LOLE results compared to 2025. So the overall conclusion we draw for the supply conditions in that the RE showing does not meet the industry 0.1 standards, and this conclusion is not expected to change if we model 2024 RE portfolio in Plexus. I will pause here for any questions or comments.
We do have a hand raised online by Peter.
Yeah, Peter, go ahead.
Yeah, this is Peter Griffiths. I'm representing myself. Could you go back a slide to page 19?
Sure.
I see at the bottom you have a list of the types of resources. Can you tell me what's in other?
Yeah, other including like some small resources like waste distillation and some small gas units, because they're really small, so we categorize those small resources in other.
So mostly CHP.
I don't have all those details in my head right now, but
Okay,
can look up.
the other question is about, you have a classification there for unknown. What's that? And why is it unknown?
Yeah. Yeah. So I pulled those data from SIRA. So not every resources have detailed information. So we can only present what's known for us. So those resources are shown as unknown in the RE supply plan, in the monthly RE supply plan.
Okay, so
which is not visible to us. Yeah.
okay, so it's not essentially, you don't know what they are, but it could be sort of any one of the types of resources you have there
Yes.
listed.
Next, we have a hand raised by Doug.
Doug, go ahead.
Yeah, good morning, folks. Yeah, so I just wanted to make sure I'm understanding this correctly. It looks like the 2025 portfolio is better than the scenario 2, which does not meet the 0.1 LOLE, but we don't actually know how much better it is, so it may or may not meet 0.1 LOLE. Am I understanding that right? That it's sort of like it's better, but we don't know if it's better enough? Or am I just... Yeah.
Yeah, maybe I can try that again. So 2025 has higher total supply capacity, which improves the total supply demand conditions compared to 2024. So our observation is because the 2025 does not meet the 0.1 industry standards. And compared to 2024, 2025 has better condition. If 2025 does not meet the 0.1 standards, we don't expect 2024 will meet the industry standard.
Yeah. I'll just add, this is Ansel. So 2025 scenario 2 is what we reviewed in October, along with the other scenarios. Those were all based on 2025 with inputs from the LSE survey, like Shuping mentioned. And so the 2024 is the backcast based on shown for last year.
Yeah.
Is that right?
Yeah.
Yeah.
So 2024 is actually showing based on supply plan, and that does not give us a better supply condition picture compared to 2025. Since we had LOLE analysis for 2025, that does not meet the industry standards. With the less worse condition in 2024, we don't expect that doing an LOLE analysis will show that industry standard can meet. We expect that the same standard will not be met with 2024 showing portfolio. Does this answer your question? Okay.
We lost him. And we do also have some hands raised in the room. Noah, did you still have a question?
Yeah, Noah Tom, Middleborough Park. Can we go one slide down? So I think similar to what Doug's questioning, what you're, maybe put another way, because scenario 2 for 2025 is 0.308, sorry, slide 20, 0.308 LLE, and 2024 is worse than 2025 scenario 2. Your expectation here is that the LLE for 2024 is somewhere between 0.3 and 0.7 or 0.8.
Correct. Yeah, correct.
Okay.
Yeah.
Next, we have Stephen.
Yeah, hi, Stephen Keene, Edison. Looking at this, I see a number of things, but I have some questions first. So that comparison would be against the 2025 demand forecast, not the 2024 forecast, correct? Because you're not actually doing the analysis.
Yeah, so the 2025 scenario is against the 2023 IPER forecast for the year of 2025.
Okay.
The 2024 showing is compared to the IPER 2022 forecast for 2024.
Okay.
So, yeah.
Then the other question I have, just looking at these numbers, can you go back a slide to
Sure.
19? Okay, I want to make sure I'm understanding these correctly.
Mm-hmm.
So what you're showing, for example, let's just look at June. You're showing that your scenario 2 had, it looks like about 2,800 megawatts less of natural gas and almost 4,500 megawatts extra of storage and 1,500 megawatts extra of solar. Am I reading that correct?
Yes.
Okay, and is that 1,500 is solar, is that nameplate or is that the?
Yeah.
It's nameplate.
Because that's how we model those resources in Plaxis.
No, that makes perfect sense. But I mean, one of the things that I want to,
Mm-hmm.
that I get looking at this is there's a big difference here between the resources. So, you know, if you look at May, there's 4,800 megawatts less of natural gas, and then there's a little bit more the solar and wind. I think that, you know, the natural gas is, the trade-off is not one for one on that. So it doesn't seem like you're taking that into account. And I understand, I'm not sure exactly how you would do it.
Mm-hmm.
But, you know, looking at these changes like July, August, and September, you're talking about 3,000 less natural gas being replaced to a large extent with storage. And storage works a lot. This is one of the things with Slice a Day. Storage works a whole lot different than the natural gas when you're running it. So I'm just wondering how you got to that, whether you took that into account in your conclusion or not.
Yeah. Yes, thank you so much for that. That's a very great observation. I would like to add a piece of information here. So the 2025 scenario 2 is based on survey data. We have a full list of showing resources. But however, when we develop scenario 2, we're trying to reduce resources to match the historical pattern where we have some, it's a little bit higher than the capped obligation. And when we reduce that, we kind of reduce a lot of gas. So this would not happen, probably would not happen in reality. But the 2024 showing is based on actual supply plan. So you can see a lot of the gas were capped in 2024 showing data.
Thank you.
Next in the room, we have Michaela.
Hello, Michaela Fly, Customized Energy Solutions. This might be kind of a nitpicky question, but how were the unknown resources modeled?
So in the supply plan, the total capacity of those unknown resources is provided. We just don't know what they are.
Yeah, but so did you assume they were like a gas resource or?
Yeah, we treat them like equivalent to gas.
A gas.
Yeah.
Okay. Are there any concerns? Because it looks like it was growing, that you could be modeling them incorrectly, and that could be contributing to some of the results. I don't know how sensitive they would be to you modeling them as a gas unit, but them actually being really intermittent or, unavailable, less available than a gas unit.
For those, I think they're probably more comparable to gas because I saw some waste to energy unit and some distillate like CHP resources.
Okay.
Yeah.
Not seeing any further questions.
Okay.
Hi, and thinking about that and have a follow-up. When you model in the Plexus modeling, when you're doing storage, how does it, I assume it's optimizing it, but like, is it allowing the storage to have more than one cycle per day, or is it capping it at one cycle per day? Just trying to understand maybe some of the limitations.
So when Sean actually did do we allow more than one cycle there?
Did not.
We did not enforce constraints.
Okay.
Yeah.
And is the energy universe confined just to the resources that are listed on the RA showings, or are there other resources that can be used to charge the storage resources?
Could you repeat the question again?
When you're running the Plexus model, and storage obviously has to charge, so you have to be concerned with how much energy there is. Are the units restricted to just the ones that are on the RA showing? Or like, are there other imports that can come in?
Import could be used to charge the battery too, yes.
Thank you.
And we did model behind the meter, like, energy only solar resources were also part of these analysis.
Not seeing any further questions.
Now I will turn over to Saeed to talk about our next topic.
Okay, thanks, Shuping. Okay, so moving on to the model improvements. Good morning, I'm Sai Kopulam, the modeling team. So today I will go through some of the modeling enhancements that we are doing and plan to do based on the stakeholder feedback that we have received over the past couple of workshops and also some internal discussions. We plan to put out an updated inputs and assumptions document along with any modeling results that we'll have based on these new enhancements. So that's coming soon. So moving on to the next slide. So this slide shows the high-level details of the improvements that we plan to make to the year-ahead model. So the main one is how we model battery resources. But just as a background to what our year-ahead model that we developed in Plexos is we developed an RA model last year to support the RA enhancements, or RAMPD initiative to develop the default counting rules and default PRM. So as part of that RA model, we created 3 scenarios that were shown in slide 20. We ran the simulations to calculate the LOLE for each of those scenarios. And as part of these updates, we'll focus on scenario 3, which is the all RA eligible scenario, and all of the updates that we are making are to that scenario. So any default counting rules or PRM that we plan to calculate will be based off of that scenario. So that scenario will have an updated resource profile based on the latest data from NKC list and new resource information from NRI. We'll also update the hydro profiles, making it more stochastic as opposed to a deterministic average profile. And we are moving away from an aggregated storage resource modeling to a more resource-specific modeling for storage resources. That should give us some more accuracy and more flexibility there in modeling those resources. And last but not least, we are updating the maintenance and forced outage rates that we originally used in our model with more recent data from the past 3 years. And this time we will be using resource-specific outage rates because the curtailment data is public, and we are moving away from class average rates in the model. Talking about the first enhancement, so our current model was based off of Plexus 8, so which is 3 versions older than the more recent version that was released. And because we are planning to do more comprehensive updates for battery resources, we thought it was prudent to make or upgrade our version of Plexus, which would give us more flexibility in modeling battery resources. So we decided to do that before we go about modeling battery resources on a more granular basis. Along with this update, we also are planning to update our operating characteristics for our conventional resources. So some of them that we use for our last modeling exercise were based on some old data. So we are using most recent master file data to update the operating characteristics of the conventional resources in this round. So moving on to the next update. So like I mentioned, this slide shows the portfolio differences between the more recent update that we are doing to the model as compared to the portfolio that we presented during the October 8th workshop. So the portfolio that we presented last year is identified as original in this stacked bar chart, and the model capacity for the more updated portfolio is identified right next to it. So original portfolio had an LOLE of 0.0205. I think it was shown in slide 20. So it had a surplus, and it was based on the NQC list at that time of performing the analysis, and also the expected new resources were based on the LSE survey. So with this round of update, we are using a more recent NQC list from January 10th of this year, and also the new resources are sourced from the NRI database with the methodology consistent with whatever we use for summer assessment and how we identify projected new resources. So you can see the differences in this chart between the old portfolio to the more updated portfolio. And more notably, I think the differences are in, I think battery, obviously. You're also seeing some gas capacity going up in almost all of the months. Solar is a bit down compared to the old portfolio, but I think it's a function of mainly the NQC list that we're using from last year to this year. So we'll stop here to see if we have any questions.
We do have a question online by Peter.
Hi, Peter.
Yeah, this is Peter Griffiths representing myself. I guess the question I have is what's in other here?
Okay, so the other, yeah, like Shuping mentioned, it's again those small resources. Yeah, it could have those CHP resources, I think qualified facilities, waste fuel, and distillate fuels. Yeah, all those categorized under other.
And are you using all of the resources that are on the NQC list?
Yes.
Okay.
And not on the other tab. Yeah, I think the NQC list has an other tab as well. But I think the way we account for that is in the new resources, which are on the other tab of the NQC list and have a specific status as active in our NRI database are modeled.
Okay.
I think that other is not to be confused with the NQC list. Sorry.
I guess I'm a little confused because when I look at the NQC list, I see that the PDR resources basically only have values for January, February, and March. And so I guess I'm a little confused as to what are you guys assuming about the PDR resources?
Yes, yeah, I did see that too. For the rest of the year, the 2025 NQC list has 0 value as shown values. So originally for modeling, I think for the last year's portfolio, we modeled PDR at their NQC value. I think this year also we'll be modeling them at their shown value, but I agree that it has a 0 for the rest of the, the last 9 months or so. But I think we will take another look at the NQC list. I think it's a new one which might be posted at regular intervals. So we'll probably pick and update the PDR values.
Yeah, are the PDR values showing up in other?
Yes.
Okay.
Yeah, it will. Yeah, I think I looked at January, February, March, and it's not that much of a capacity. I think it's probably like 100 megawatts NQC for PDR resources, as opposed to, I think last year they were in the range of like 300 megawatts or so. So yeah, I think there's definitely a difference between how PDRs are represented here.
Okay, thank you.
Yeah, thanks.
I'm not seeing any other questions. Oh, we have a question in the room from Stephen.
Hi, Steve Keen, Southern California Edison. I think it's September, it looks like going from the original to the updated, the amount of solar and the amount of storage went down. Can you just explain what was going on there?
Yeah, I think it's definitely a function of, I think the variables here are like the NQC list. So if a resource is not shown in the 2024 NQC list that we were using for the original portfolio and shown in the 2025 list and vice versa, I think we could see those differences. But also, we are using the LSC survey to capture new resources in the original portfolio. So if some of those resources, new resources, did not show up in this round of update where we are using NRI database, then I think that could be another difference. So maybe, yeah, more resources in the survey as opposed to what we are seeing in the NRI. Right.
Not seeing any other questions.
Perfect. Thanks. So moving on to the next enhancement. Yeah, hydro modeling. We are updating on how we approach hydro modeling as well. Originally, we were doing a more deterministic approach of using an average hydro year for all of the 500 cases that we run to calculate the LOLE. But this round, we are using a more stochastic approach for hydro modeling in line with how we do for solar and wind as well. So we're moving away from that deterministic approach. So in order to do that, we are using the past 25 years of hydro data partially sourced from CEC during those early years before CAISO. And then the rest of the data is sourced from CAISO. And the next slide I have here should show the frequency distribution of annual energy sourced from those 25 years. So we just categorize them into bins, kind of just showing a different range of hydro conditions over the past 25 years. And the 2018 average hydro year that we used in our last round of modeling, it's between that third bin, 16,000 gigawatt hours to 20,000. So we use this frequency distribution to create these random samples for hydro. And so we'll have 500, 8760 hydro profiles as well, which follow this frequency distribution, and the energy limit and the energy for each of those 500 samples would fall in these energy limit buckets. So for example, I think this slide shows the 20% of the hydro samples in that 500 profiles would be sourced from the third bin, and 32% would be from that fourth bin. And then we would run the same model with 500 load profiles, solar, wind, hydro. Also, we have an outage variable which is stochastic. So it's a total like 500 simulations with varying conditions. So do we have any questions before we jump to another slide?
We have Stephen King.
Hi, Steve King, Edison. I just want to, is there any connection between the hydro years and any of the other weather-related
No, no, yeah, there's no correlation. Yeah, they're entirely randomized.
Okay, thanks.
All right. Oh, sorry.
We have another question in the room.
Sorry, Eric Little from Cal CCA. Have you taken a look at, if you look at the buckets here, the bins that you've got, have you looked at what years fall into where? I'm just curious if the recent drought conditions have tended to fall more in that first two bins than anywhere else. And so I'm wondering if from a historical trend perspective, if that gives you any information rather than just assigning 12, 20, 20, 32, 12, and 4% in pulling your samples.
Yeah, I can. So I think, yeah, they're entirely randomized. So yeah, cannot explicitly say like which years fall into like which. But as you can see, the 2018 hydro year, I think that's from that third bin. But because these are random, it is like possible that in our modeling, a high load sample could technically have a dry hydro profile. So yeah, I think yeah.
One more caveat, this distribution will only be modeled in any of the resource adequacy assessments where we don't know exactly, but when it comes to analyzing the prompt year summer, we will use the known summer conditions.
Yeah. Thanks for that clarification. Yeah. So.
Not seeing any other questions at this time.
All right, thank you. So moving on to battery improvements. So like I said, the past, I think 3 versions of Plexus had significant improvements in how we model batteries. So we decided to upgrade and then do improvements to battery to be more resource specific. And this next slide shows how we are planning to do that. So originally we were presenting batteries as pump storage units on an aggregate basis. So we had just 4 different aggregations of battery resources based on zone, and they were using a pump storage model. But going forward, we will be using a more dedicated battery class within Plexus and resource-specific modeling with their respective operating characteristics, such as the model of the round-trip efficiencies, ramp rates, energy limits, and all of that. Although I think for batteries which are I think less than 30 megawatts in size, I think we'll still model them as an aggregated basis. I think obviously I think modeling batteries in this detail will definitely increase the number of constraints and also the runtime. So I think there might be some performance improvements that we might have to do, but I think this is a good start to get a more detailed modeling of battery resources. The last bullet point, yeah, we are sourcing the battery parameters from custom master file, and if we were to make the model public, I think we were cautious about what parameters that we'd have to average and what parameters that can be used. So I think we took that into account when modeling individual resource characteristics for battery resources.
We have a hand raised in the room.
Hi, Eric Little from Cal CCA. What are you assuming about the number of cycles per day for a short duration battery?
So I don't think we are explicitly enforcing the constraint right now in the model, but in terms of like operations of what we've heard is I think battery operators, they generally don't like the battery to be cycled more than once in a day. But technically, I think in the model we're not enforcing any, so we could see multiple cycles in the model. So
I'd like to add one more thing. So there are things like battery cycles, GHG emissions, and all of that we can always do an after the fact simulation, go and look at how many times it has been cycled instead of an upfront enforcement. And if there are multiple batteries having multiple cycles, then that can be an additional constraint enforced in that case. We are going to be looking at that for sure. So.
Yep. Yeah. Thanks, Aditya, for that. And yeah, I would also like to add that we're also looking at, in terms of like battery operations, do we enforce any kind of explicit constraint on state of charge? like between like 5 and 95%, similar to how currently the battery resources are operating between those limits, and not allowing the battery to discharge all the way up to 0 or charge all the way up to 100%. So I think there's some thoughts around that as well. All right, so moving on.
We do also have one hand raised online by Peter.
Yeah, this is Peter Griffiths representing myself. So is there a plan basically to look at sort of what you're assuming about batteries and check it against the way the batteries are actually operating in the market?
Yes. Yep. Yeah, I think that's the plan. I think once we have this model up and running, I think we are planning to like an after the fact check, see if it's in line with how the batteries are being operated in the market, like from a state of charge, limits perspective, number of cycles, and all of that. So
And then make adjustments to the assumptions in the modeling.
yes, obviously, yes.
Okay. All right, thank you.
Not seeing any further questions. Oh, we do have one from Noah.
No, from Middleware Power. Can you talk a little bit about pump storage hydro? Are you separating that from hydro as a class and batteries, or are you treating the pump storage hydro as a 4-hour, 8-hour, however long hour battery in Plexos?
So for pump storage, I think we're modeling them individually, resources, so Helms and all of that. I think for batteries, we were modeling more on a zonal basis. So I think we had like 4 different like battery aggregations depending on how much battery capacity was in that zone. So with this update, we are moving all of those batteries into its own class within Plexos.
Sorry, the batteries being its own class is separate from the pump storage hydro class.
Yep.
And are you also enforcing energy sufficiency for the pumping?
I think so, but I'd have to take a look. Yeah, I think the we will update the INA document with more details on how each of the technology types are being modeled.
Not seeing any further questions.
Okay, perfect. Yeah, thanks, Christina. So moving on to the last part of the slides here. I think the most interesting, I think, is the outage rates and the updates for the outage rates from our last modeling exercise. So with this update, we are planning to update both the maintenance and forced outage rates. And this slide shows the natures of work that we are including for forced outages to calculate the rates. So we are using OMS data for the past 3 years. And the idea here in this slide is for modeling specifically, these are the outage rates that we are including for forced outage rate calculation. And the idea is that right now it doesn't include some of the outages outside of management control. Although I've recently learned that transmission induced is technically, I think, within the ISOs, the control on when to approve transmission outages or not. So I think we will have to take another look at that. But all other like outages such as ambient due to fuel insufficiency and not due to temp, I think they're excluded for now when calculating the forced outage rates. And also like ambient due to temp nature of work that is separated from the forced outage rate calculation, and it's its own category. If you remember, the outage variable is stochastic in nature. So we decided to separate the ambient due to temp variable from forced outage rate and have its own category. And I'll go into a little bit more detail with the next few slides.
This is Aditya Vidya. So maybe I want to not clarify, but add one point here. When we looked at these different natures of work and outage rates, we thought of it from a standpoint of what works best for modeling. But when it comes to UCAP discussions, these can move from one category to the other category. So when size talks about ambient due to temperature. That will be a default derate applied to the resources because that is the physical characteristic of the resource. So that is one area. Planned outages, we tried to pull the natures of work that align with that planned outage modeling rate. Forced outages, as I explained, forced out when you can think of that. So that's again varied by resource by month. And then there are other events like Sai mentioned, we did not model. But if you feel that something should move across the columns, do let us know. We did a few trial and iterations based on logic, based on data, and then we made some adjustments, and this is a pretty decent list. Thanks.
Yeah, thanks for that clarification again, this is more specific to modeling, and Ansel's going to talk about UCAP and how natures of work will impact that calculation, but we are definitely open to feedback there and take that into account and update the rates as well. So moving on to the next slide. Oh, yeah, go ahead, Noah.
Can you talk a little bit about metering, telemetry, rig, and well, I'm going to stop there because I don't know I don't even know what ICCP stands for. Do those outages or natures of work take out a plant and thus reducing a resource's generation capacity? Or do they simply, it's an outage for the ISO to notify the ISO that something's on the metering telemetry side is wrong, but the unit can still continue to operate?
From a data perspective, yeah, I think they're more like equipment failures and hence like forced out. But when we look at the data for those natures of work and forced outage, we do see like either like derates or completely the resource being like completely out. So, out in the field, yeah, I'm not sure if that would like get the turbine like completely off. Like it's generating, but the meter that is that's transmitting the data to ISO is out. Yeah, I'm not sure about that, but in terms of like the OMS data, this would capture any like full outages or derates. Yeah. All right. So moving on to this slide. So this slide shows just to give an overview of how much the outage rates that we are applying to would have an impact. This just gives a sense of the model capacity by technology types. Obviously, we have combined cycle battery storage and gas turbine making up the bulk of the model capacity. So I think the slide was more put in here to give a sense of how much the outage rates would have an impact, because I think some of the distributions that we see over the next few slides might swing a lot higher, but for some of the technology types, but having this in mind would give you a sense of, okay, that wouldn't impact that, that much capacity because they're modeled in this range. So, okay, so this slide is specific to ambient due to temp derates. So what this chart shows is resource-specific data for ambient due to temp derates from OMS, and the historical data is from 2020 to 2024. So we use that resource-specific data filtered for ambient due to temp derates and calculated an average monthly rating for each of those thermal units. And this chart shows the distribution of that. So for example, a resource with 80% rating, in any month means that that resource was available like at 80% of its Pmax when it took an ambient due to temp derate, and will be modeled accordingly in the model. So we'll have for each of the thermal unit, we'll have a monthly profile with these monthly ratings. So that's how we're capturing the ambient due to temp derates. The average sort of seems a little bit conservative as opposed to, let's say, like a maximum rating, but I thought this was a good starting point to model and to consider these ambient due to temp derates. But we are definitely open to stakeholder feedback, and we will incorporate anything that would come out of the ambient due to temp policy from track 1. So if you look at, for example, July, we have the area under that box, the red box should cover 75% of the thermal units, and it means that 75% of the units have a rating, I think, of 95% and above. So they are available 95 on average, 95% and above in July. It's based on the data of the past 3 years.
We have a hand raised by Brian.
Very short cord. Brian Taker with Middle River Power. Forgive me for not getting my card up. May we go to slide 30 for a quick question?
Yeah.
You are showing capacity, gas turbine, and frame turbine separately. Is that because of a difference in the outage rates? Why are you displaying them separately?
Yeah. So this categorization, I know frame turbine is a subset of gas turbine. This categorization is based off purely from master file and how they are categorized in master file data. There is a variable in master file which identifies if it's a frame turbine or a gas turbine. So this description just basically just follows that term. Yeah. But yeah, I did look that up, and yeah, frame turbine is yeah. Okay. So any more questions, Christina, or are we good?
I'm not seeing any other at this time.
Yeah. Thank you. So moving on to the next slide. So this slide shows again resource-specific distribution of planned outage rates. Again, calculated using the last 3 years of OMS data. So each data point in this distribution corresponds to an average planned outage rate in that month, and this data is organized by different technology types. So if you pick an example here for combined cycles, and even for most of the other resource types, for planned outage rates, it shows a seasonal pattern, which is expected in terms of how much planned outage rates for different technology types. On average, I think you could see the dotted line, which tracks it's a simple average, which could be inflated by some of those outliers. But specifically, I think if you pick for combined cycle units, as shown by that big box and whisker plot, let's say for the month of April, you could see on average the planned outage rate for combined cycle units somewhere between 10 and 20%, as shown by that dotted line. And the number of units covered by that box plot, or just the blue box plot, is 75% of the units. So 75% of the units, combined cycle units, have a planned outage rate of less than 30%. And it's really tough to see on the graph here, but there is also a small, a medium, a small median line within the box. What it basically shows is the median is very low compared to the average there. So you could just see how the data is skewed. So driven by those outliers.
We do have a hand raised by Eric.
Eric Little, CalCCA. When you say 75% of the units, do you mean units or do you mean capacity of the units?
So it is 75% of the units. So for example, I think this distribution has probably 70 combined cycle units, so 75% of those units. Or I think the other way to read this is, for example, for the area above the box, you could have that represents 25% of the units. So for the 24% of the units, 30% of the capacity is like unavailable. Or for 75% of the units, 30% of the capacity is, up to 30% of the capacity is not available. So yeah. All right, so I think that's it from this distribution here. So moving on to the forced outage rates, again, the same way the data is presented. It is resource-specific data in this distribution organized by technology type. These forced outage rates are average rates calculated from OMS from the past 3 years. So again, each data point in this graph represents an average forced outage rate for 1 unit. So if you pick, let's say, like battery resources, I think that's more interesting, I would say. For battery resources, in July, so number 7, there, I think we have an average rate of close to like 10%, shown by that dotted line there, and in like 75% of the battery units represented by that box have a rate, I think less than, I think like 12, 13%. So again, I think the average is a little bit higher because it's a simple average. I think even higher by those outlier units, and you could see there are some. I think there is only just 1 unit which has like 100% forced outage rate. But looking at the data, I think it was an old battery resource that was retired back in 2022, so it just was shown in the data. But I think we will use average class average rates for any new resources because they don't have any OMS data. So I think maybe it is good to factor that into account, maybe like a capacity weighted average rather than a simple average if you're going to use average values for any new resources. Okay, so before I move on, okay.
We do have a hand raised by Chris.
Yeah, Chris Devon, TerraGen. On the hybrid one, can you explain how you guys are looking at the hybrid capacity? Is that the storage portion only, or are you looking at the entire capacity shown, like NQC capability of the unit there?
Yeah, so for the hybrid resource, I think the way we are modeling is because we have data on individual components for solar and batteries, we are modeling them separately. So batteries we model their nameplate, solar also nameplate, but based on the production profile. But we will enforce a constraint that would limit the capacity up to its Pmax for hybrid. I think the same concept would apply to co-located resources as well. We are modeling them separately, but then we would limit the output from those resources to the point of interconnection limit.
Okay, so based on the battery component forced outage rates, that's what you're applying here basically in this chart.
So for hybrid, it is based on, again, like master file categories. So master file has a field which identifies hybrid units specifically. So whatever I think hybrid units are reporting outages in OMS. I think that's how it's categorized here. But I do see your question in terms of how we apply that from modeling perspective. So for hybrid, we're still not like sure. I think we're getting some clearance there. But if you want to model them aggregated or like individual resource specific because of confidentiality concerns of component level data. So if you are going to like model some kind of aggregated basis, I think we might have to do some sort of like average rate based on the hybrid data here.
Okay, yeah, I just asked because it seems like if you're capturing the outages on the solar or the wind side of the verse side of the unit already, and then you're maybe overly inflating the impact of the battery outages on the overall, or not capturing the full impact potentially. I'm not quite sure, but I just wanted to flag that because of those underlying components. It seems like the forced outage rate for the battery would be kind of similar to other batteries, but the overall impact on the entire amount of net RA going to the grid may or may not be impacted the same way, I think. And it also does get complicated because of the POI limit, as you mentioned. So some of them, can go over the POI depending on if the battery's operating or, would be constrained, by the total amount of POI limit too. So just maybe think through that more. If it actually has a big impact or not, I'm not sure, but I just wanted to mention that. Thanks.
Yeah, thanks, Chris. Yeah, I think it makes sense. Yeah, if you're modeling batteries separately, I think it would make sense to maybe model the outage rates for that in line with other battery resources, because we're not explicitly parsing if it's a war outage or a battery outage from the hybrid data. It's whatever comes in through OMS. And the way we model solar and wind resources, we just model nameplate and based on the production profile, so we're not modeling any explicit outage rates for work profiles. So
yeah, so if you don't actually have the explicit component that says this part, the wind or the solar is out, or this is the battery that's out because it's an integrated unit, I can see why you're doing it this way. So fair enough.
Thanks, Chris.
Not seeing any further questions at this time.
Thanks, Christina. And moving on to the final slide. Like I mentioned in the first slide where we looked at the natures of work of what outages that were excluded from the forced outage rate calculation. So this distribution shows the outage rate if you only consider natures of work which are categorized as outside management control, which are this ambient not due to temp and ambient due to fuel insufficiency and any transmission induced outages. So this distribution shows on a resource specific level what's the outage rate if you only include those natures of work, and it's generally low for gas technology types and also batteries. There are some outliers there, but generally very low, mainly impacting these biofuels and geothermal resources. So yeah, we did take a look at those natures of work, and typically they're low for gas and battery storage resources. So yeah, I think that's it from my sections. Any questions?
I'm not seeing. Oh, Stephen, do you still have your hand up?
Yes, I had one quick question. With the battery storage, one of the categories that you listed as outside of management control was, going back to it, just ambient due to fuel insufficiency. Does that apply to batteries?
Typically, I think it's only for gas resources. But I think for mainly for battery resources, I've seen transmission induced outages, but not so much ambient due to fuel insufficiency.
Okay. They're not using that for a state of charge.
I think for state of charge, they're more using plant trouble, I think based on new ISO guidance to manage, the state of charge or any fallback limitations. So that's, captured in plant trouble.
All right, thanks.
Hi, David. Yeah.
Hi, this is David Zoll from the ISO. I can confirm the nature of work for ambient due to fuel insufficiency by definition is for gas and hydro.
Yeah, thanks for that.
And again, for specific scenarios that apply to those resources. So by definition, it couldn't apply to storage.
Okay. Yeah, thanks for that clarification, David. And any more questions?
I'm not seeing any. Noah, do you have a question? I'm not seeing any other questions. So with that, we'll take about a 15-minute break and return close to 10:40.
But yeah, thanks, Krishna. Thanks all.
Thank you. Hi, everyone. We're returning from break, and we're going to get started with default counting rules proposal options with Mark.
Thanks, Christina. This is Aditya. Before I pass it to Mark, Just give a little more context. When we talked about default rules, it is mostly historically at least observed to be used by non-CPUC LRAs when they refer and use our default rules. So we wanted something that is a little bit straightforward, simpler to apply, for some of the guiding principles in how we've come up with these different proposals based on feedback. The idea when we do talk about QC counting rules, we can explore different methods of counting, mix and match, and do stuff like that in the counting rule space, but then that default PRM is what it comes up to be, is what the answer is. After we make all of these modeling improvements in our model, we're almost getting in the last phases of testing the base models. So we should have a good model in the coming weeks. So in about 2-3 weeks, we should be able to calibrate the model to see which portfolio gets us to a 0.1 loss of load expectation. And then we'll be able to explore counting rules and then apply them and come up with some data and information-based values for you all to look at. I'll pass it to Mark to give a quick overview of definitions, and then we'll go through the different proposals we have laid out for discussion today.
Thank you. I'm Mark Kuchler with the CAISO. So we wanted to lay out some definitions that we're using in here just to make sure we're all on the same page for what terms, or what we mean by the terms we're using in some of these approaches. So average ELCC, we're looking at the effective load carrying capacity for the entire resource type and portfolio. That's all solar, what that resource provides as a whole. Marginal is really just looking at that marginal value, either that first, the last megawatt, depending on how you're calculating it, megawatt of that specific resource type, the value that it provides to reliability. So looking at that from a marginal standpoint, exceedance is really that representative profile, or the amount of generation you can reasonably expect from the resource for it to produce. And then that planning reserve margin, this is the equation that we would use for basing that planning reserve margin off the peak load. So it's the total qualifying capacity that you need. Whatever measures you're using to get that qualifying capacity is the total amount that you need from the portfolio to get to that 0.1 LOLE. So that's how we're looking at the planning reserve margin for this. Looking at critical periods, and this comes into play for the marginal ELCC approach that we explored and was discussed in November. That's periods when an additional available capacity or reduction in load would improve reliability by reducing unserved energy at that hour or at that time or at a later time. And this is only used for our marginal ELCC approach using critical hours, the critical hours framework. At-risk hours, this is hours that we can look at or we can use for reasonably expected output for approaches that use that. Right now, there's many ways we can look at what those critical or that at-risk hours are. We haven't settled on. We're not proposing specifically. We're just wanting to look at different ways that we can look at it. Are we looking at hours where we have loss of load, but only in samples that have loss of load? Are we looking at all of our stochastic samples and the hours where loss of load occurs? Are we looking at some sort of supply cushion where the amount of excess that we have goes down to a certain amount or the top hours for that? And that's something that we'll continue to look at as we develop our default proposal. Some key considerations, Aditya went over a lot of these. The big here is that we want to make sure the qualifying capacity counting rules reflect the contribution that resources provide to reliability. We want there to be that link and that it provides values to LRAs, specifically those LRAs that might use this. We want to make sure that the valuable thing is useful and gives us some insight. And we want to make sure that our default qualifying capacity and PRMs work well with UCAP and other procedures that we have at the CAISO. We want to make sure that things are pretty smooth where we can and to be reasonable to update so that we can keep as relevant as we can. And we also do expect to update these or at least review them periodically, say every 2 to 3 years, and update as appropriate. Just because we review them doesn't mean we need to update them, but we want to keep an eye on that to make sure we're doing this as need be. This is a slide from Kevin Carden from Astrape, now PowerGen, his presentation in November, just to show that there are different approaches out there, some marginal, some average, direct loss of load with MISO, and other approaches that are out there, and those can change over time. We aren't required to keep the same default approach in perpetuity. We want to look at what makes sense for the resources that we have, for the system we have, for the LRAs. And if that needs to change over time, we can change it, but we want to have something that's providing as much value as we can. So right now we're looking at, or we have 4 proposals that we're looking at. Proposals 1 and 2 are the ones that we're still actively considering at this time, but we still would appreciate input from folks on proposals 3 and 4. Proposal 1 is a reasonably expected output, and I'll go into a little bit more detail on that, and that's a hybrid of what we can expect resources to provide at hours of risk and an average ELCC. The average ELCC approach is average ELCCs. This is similar to a PCAP for all resources across the board. And then proposal 3 is the marginal ELCC based on critical hours. This approach was presented in November by E3, and that would be the marginal contribution of those resources to reliability, focusing on hours where an additional megawatt of capacity could provide support and improve reliability. Proposal 4 would be a 24-hour monthly peak day stack that uses ambient derates and UCAP for accreditation for some resources, predefined dispatch hours for storage, and exceedance values for other resources. And this would need to look at the peak day as opposed to proposals 1 through 3, where the PRMs will be measured against managed peak. Looking at proposal 1. Oh yeah, I can pause. If there are any questions in the room or on. Yes.
Eric Little from CalCCA. So maybe I'm not understanding how you're using marginal ELCC for this, and forgive me, but my recollection of marginal ELCC was from a while ago and having discussions about how a specific resource counts, right? And the problem was average ELCC every year was going down, right? So you added more solar, and the resources that you bought prior to that are getting derated and derated and derated. And the concept was if you went to a marginal ELCC, they kept whatever they were when they came online. They kept that in perpetuity. Eventually, it got to a point where a new resource, there wasn't any point in doing it from an RA perspective because it counted for 0. Where you're doing a study here, though, and you're trying to set defaults for the qualifying capacity, are you looking at then a default for qualifying capacity based upon when the resource came online to do a marginal ELCC, or what exactly does that mean?
This would be looking at the fleet-wise, so all solar resources, the marginal value of the next resource, and applying that to all those resources. So this wouldn't be the vintaged approach, which was discussed in November in more detail. I'll have a slide that kind of talks about that a little bit and shows some images about that. But again, this isn't something that we're proposing to look at heavily at this point.
Okay, thank you for the clarification.
Yes.
Chris Devon, TerraGen. So if you were to choose one of these, I guess under any of these that use it, either the average or marginal, you CAISO would be doing a study during this, general assessment LOLE process, and then publishing a default rule ELCC every year to apply.
That would be the hope. Maybe not every year, but we would update it periodically. Yes.
Okay, thanks.
Stephen.
Steve Keen, Southern California Edison. Just a couple of questions with the average ELCC, following up on what they were saying. I mean, given how much storage has, the growth of storage over the last few years, even if you're updating the average ELCC for storage every other year, that's going to be pretty far off, isn't it?
It could be. We'd have to look at it. And that's something that we want to consider. And it's a consideration of how easy it is to update and how often that would need to happen.
Okay, and I guess my assumption is that it would be dropping fairly. We've seen big changes in the past on that, the ELCCs, but I guess I'm just wondering how that would work for some of the LSEs, because I could see fairly big drops, like from one year to the next, and what their resource stack is.
Yeah, and that's something we'd like to get input on to make sure we're capturing that and accounting for that situation. I think that that's going to be a challenge with every resource, but it's pronounced with storage and resources being heavily added.
Okay. Then the other question I had is just,
Steve, maybe a quick point to add there. We also plan to do a 10-year forward look assessment on an annual cycle. So you will have forward looking insight of what that will be based on different portfolios into the future. The portfolios can be informed by the preferred system portfolio or the LSC plans or whatever that we have to finalize. So the idea is to give that forward-looking view from an RA standpoint.
okay. The other question I had is, proposals 1 through 3 are measured against the managed peak. I'm assuming that that's the complete peak, not the net peak. Is that correct?
Correct. Yes.
Okay. So are you looking at anything that would maybe help? Because it seems to me that one of the problems you've had, where the problems show up, where the LOLEs start coming up, is during the net peak and not so much during the peak. Are you looking at anything to kind of address that issue, or?
Depending on how we make use of this, that the issues being at net peak should get captured, and the contribution and reliability those resources have towards that net peak would get captured. Even though we're doing measuring the PRM against the peak, that impact at the net peak hour should still be captured. I think with the marginal ELCC, that does look at the resource. The resource need is really looked at heavily where we have issues or concerns, but the PRM can still be measured against the net peak load or the managed peak load.
Okay.
Yeah.
Thanks.
We also have a question in the chat from Allison Campbell asking, what is managed peak?
The managed peak is essentially the peak forecast that comes out of the California Energy Demand Forecast from the Energy Commission. So it includes the impacts of behind-the-meter resources, energy efficiency, additional achievable energy efficiency, and other items as well. But it does not take into account things like the solar that's on the grid to change it into a net peak. It's effectively the load seen by the system.
Thank you. I'm not seeing any further we have a question from Noah, and then we'll go to Michaela.
Noah Tom from Middle River Power. Can you help me understand here the result or the product of this, whether it be proposal 1 and 2, where does it flow into? What does it flow into? What's the problem we're trying to solve? Does it flow into CPM? What does it flow into?
Partha, did you want to?
Yeah, and Mark and Aditya can talk more about for the modeling purposes. Obviously, I think that they laid out was that, we've seen, as a part of the working group's process, we identified that our default rules were out of date. We'd indicated that a number of the LSCs or LRAs, particularly the non-jurisdictionals, were actually looking towards our default rules, when applying their counting rules and PRMs within their program. So we felt like just for that purpose, it needed to be updated. As you alluded to before, we're going to have a longer conversation in terms of, for example, like our reforms to our backstop process via track 3 coming up. Certainly, this is not, we're making no assumptions that this being applied directly to those processes, but really trying to focus in on making sure that the default rules that they're relying on are up to date, given the fact that, when we reviewed them, they were, what it looked like is lacking in meeting sort of reflecting the reliability contribution of different resource types and meeting a 0.1 LOLE. So I think that's what we're focusing in on before we got to those policy reforms.
Thanks, Partha. I mean, what I'm seeing is primarily, different LRAs utilizing other default count or other counting rules rather, and we can see that this year in the difference in the exceedance methodology that's being utilized by the PUC that's impacting other LRAs and the capacity that we see on the NQC list.
Mm-hmm.
And so I'm just trying to figure out, we're spinning our wheels here, trying to design a system, but I don't see where the ultimate, goal is still. Because the PRM, if the ISO's tariff defaults to other LRAs, certainly for I guess the short term, I'm not sure what the problem is we're really trying to solve.
Aditya, if you wanted to answer.
Yeah, you also have to think about this as a compartmental problem. The only thing that we're trying to resolve here is update the default rules such that if LRAs were to use those rules, you would be able to get a 0.1 portfolio in the end. Right? That's the only objective, and that application is only for those LRAs that don't have or would like to use our default rules.
To which I don't think there are any, right?
Currently, there are not. Currently, there are not anyone who does not have their own qualifying capacity in PRM.
Yes.
But that does not mean folks will not use it if it's updated, and we need to have something that's up to date in our tariff. And Partha, do you have something to add?
Yeah, I think it's the applied by the ISO. They don't. What we heard feedback on is that they do look to our default rules when setting the counting rules and the PRMs within their own program designs. And so, to me, for that reason, at least having clear, actionable information that they can use to be a 0.1 LOLE seems like a important step that we can help them take in terms of meeting the collective reliability needs.
And this is Abdul, just a minor correction. We do have some LRAs that use our default PRM today. They actually use it. And some of them look to it, to Partha's point. They look at that PRM and utilize that to decide if they want to adopt it. And some of them do their own thing, like the PUC. But there are LRAs that actually use our PRM, so updating is critical. The counting rules, on the other hand, nobody uses them as of now, but we still need to have an appropriate and reasonable and up-to-date counting rules in our tariff.
Yeah, I mean, then if an LRA is choosing to use the ISO's default PRM, but elects to not choose to use the ISO's default counting rules, then aren't we comparing apples and oranges for purposes of compliance?
I think that's a fair problem.
Yeah.
Mark and I discussed this. And Mark, you go ahead.
So
I was not at that meeting.
At least I'll say no to. I think we're jumping the gun here. I think that's like Aditya laid it out well. Like the purpose here is to really update those default rules in this. I know we'll have many more opportunities to discuss, reforms to our various processes and procedures, but I don't think that we're really that's probably a much broader conversation in terms of how that might be about updates to our CPM, our role in backstop and things like that, which I think is what you're alluding to.
Well, I guess my question is if there is a longer conversation to be had, what track is it under? Is it specifically under 3A or is it somewhere else? I think we should put that on the agenda, or within scope at least.
Yeah, I think it is 3A. I think it's primarily what you're alluding to is 3A. I think there'll be sort of some overlapping discussions in terms of track 2 or these type of topics will come up, but I think it's primarily 3A.
Yeah. Thank you. And Abdul, thank you for the correction on the PRM. I appreciate that. Forgive me, there's a question in the back. I can't read your name text sideways from this distance.
No, it's okay.
Michaela, thank you.
Michaela, yes. This would be on an annual basis.
Updates?
Annual, not a seasonal approach. It would be one annual.
Not necessarily. That's something we could appreciate some comments on. We haven't proposed one or the other on that.
Okay. And then is there concern that this could be resource intensive? So if you're calculating marginal ELCCs by resource class and PRMs every year, potentially out in the future too, because I know that's a concern in markets that have moved towards marginal ELCCs, that they want incremental forecasted values if nobody uses it.
That is a consideration that we have, and you'll see in the next slides that resource intensity is a consideration. Yeah. Doug, you have your tag up?
Yeah. Doug Carpa, Peninsula Clean Energy.
I guess I'm still a little befuddled again. So if nobody is using the default counting rules, but they are using the PRM, it seems like there's a bit of a issue there in that the PRM is dependent on what the counting rules are. Like if you give more or less credit, the PRM is going to go up or down, which does seem like that would be a bit of an issue for the system as a whole. If like you're using a PRM that's based on, say, fairly stingy values, and then you adopt high values, then you've got a mismatch there. And if that's the case, it seems a little bit that we'd want to avoid that mismatch, which might mean thinking first about how people are using this and like what other rules, like particularly around the counting rules, are going to get used. And then once we know what that is, then we can kind of backfill to what the defaults should be. Because it seems like we wouldn't want to have one set of rules that are commonly used and then a default that's actually quite different, and then a PRM that comes from some default rules that are different from what's actually being used for counting, because then you're ending up with a PRM and counting rules, like de facto counting rules that are not aligned. But maybe I have that completely backwards. So
that is a concern that we
Okay.
need to look at, and that did inform some of our decisions on which proposals we're leaning towards at this point.
Bit of a chicken and egg problem.
A little bit. Yeah. Ansel?
This is Ansel. Just also to kind of play off what Partha shared earlier, and to your point, Doug, I think, in our issue paper, we outline kind of a similar observation about a mismatch of, if you will, counting rules and a PRM that don't kind of add up holistically. And so I think, even my question in the issue paper is, even if there were an LRA that wanted to adopt our new set of rules, including the PRM and the corresponding counting rules, in our current systems and our NQC processes, there are details that could prove that to be a little bit more difficult than just straightforward, okay, here's a list of QC values that an LRA could adopt, and here's the corresponding PRM. For instance, if a resource is shown by two or under, two LSCs that are jurisdictional to different LRAs, then our systems defer to the highest value. So there are little kind of intricacies like that I think we will probably talk about more, in the straw proposal discussions. So just kind of flagging that for something that we would like, feedback on from our stakeholders. So yeah.
Thank you.
We do also have a question in the chat from Paul Nelson at CPUC saying, please define what is peak day under proposal 4.
This would be the peak day for each month at this point. So I don't remember the name of the forms, but the California Energy Demand Forecast does identify a peak day forecast. So it would be that forecast. Oh, yes, sorry, Eric. I can't.
Eric Little, CalCCA. I just want to say, I think we're having a conversation about something that we honestly can't fix, okay? An LRA can decide that their PRM is negative 42%, and the resources count at PMAX plus 15, right? Mm-hmm. We can't stop that from happening. It's a state right program, and the LRAs are going to decide to do what they want to do. I don't think that trying to make sure that they perfectly match is necessarily the objective here, as much as it is for the ISO to educate the LRA. If the LRA comes to them and says, I want to use your number, but I want to do something else for QC, it should be the ISO that educates them to say, those are developed in concert. The two are actually dependent upon one another. It's really not a great idea to separate them out. If that's what you want to do, because it's your right to do that, you can, but you really shouldn't separate them out. So I don't want to get in the stakeholder process where we try to figure out what is every way that the LRA is going to make a mess of this and try to prevent that from happening, because we can't. So let's not be so hung up on that as we are in trying to develop something that does work together, and then once you have something that works together, educating those who want to use one piece or the other, but not both.
Thank you, Eric. Aditya?
At one point, Partha proposed this and I pushed back, but I wanted to see if that's a good idea now, which is, should we also consider giving a resource ID by resource ID and default counting value and a default PRM post that as a spreadsheet? Yeah, so Hmm? So right now, the counting rules, we give a percentage or whatever, right? So we can also, like how you post the NQC list, we can also post a default QC list if that is of interest to alleviate that problem. Then they know, yeah, as a reference, so they can look at the default value and then the PRM will be a function of that. But education, go ahead.
I think, Middle River proposed sort of a transition tool or translation tool for the ISO to present and such that to what Eric is saying, regardless of what the LRA wants to do, what the ultimate number that the ISO can translate into to ensure 0.1 LOLE should reside with the ISO. And if that's a conversation to be had at 3A, we can wait for that. Just let us know that will happen. If not, then I think it belongs within here to get a better understanding of how the PRMs are relative to all the different counting rules from all the various LRAs at the end of the day. Thanks.
All right. Yeah, and to add another layer of complexity to that, there is a NERC BAL standard, BAL 7, that requires, from an operational time space, to think about 5 days to 6 weeks in advance to see if you have enough energy sufficiency for every hour. And that our RA program on a monthly basis also falls in that 4 or 5 week window. If that is something that we have to think about, we have a NERC standard to. Yeah, like I said, but that's a compliance that we have to start developing. But it might not be an RA-related aspect, but more operations. But that's where we can get into that hourly sufficiency and peak hour, net peak hour kind of stuff. Thanks. Back to you.
Thank you. So starting to look at, I'm jumping ahead. I hit the button already. So proposal 1, it's that a combination of the reasonably expected output for some resources, as well as an average ELCC for others. The figure on the right is very much just for illustrative purposes. Please don't take those numbers as anything meaningful. Looking at, energy storage, hybrid resources, and gas resources as having an expected availability of resources that are expected compared to an average ELCC. Some of the positives we see with this is it's going to be a little bit less computationally intensive to put together, because we can hopefully, with a single run or a small number of runs, or looking at historic data, understand what that availability is for most of the resources, what that would be assessed to, and then we need to look at the ELCC resources through simulations. In this case, the qualifying capacity values are directly tied to the ability of the resources to provide reliability. But because there's 2 different measures, we do look at this being QC values that are not necessarily interchangeable. So they may not be perfectly interchangeable, even if they're pretty close. And the interactive effects between all resource types, such as those that are assessed by availability versus those assessed by ELCC, they may be slightly different. You might not be able to capture everything there. Something that's in addition here is that the assessment of availability of resources in critical hours or at-risk hours may be designed or adapted to work very well with UCAP. So there could be some alignment with that. Yes, Eric.
All right, is the categorization there, is that based on any experience? What I'm getting to basically is, why is hybrid in the lower category, not in the upper? I'm assuming that hybrid resources are going to be ITC resources, meaning that the storage is only charging off of the host resource. And so from that perspective, it seems like the output looks more like a wind, solar, hydro facility because it's dependent upon its fuel, as to where the others look like things that their fuel source is either guaranteed or they can charge off the grid. So I'm just curious about the one category of hybrid looking like it's down in the availability assessed resource rather than the LCC.
And that's something we'd appreciate comment on if folks think it should fall one side or the other of these resources. But it's also looking at if energy storage is assessed by UCAP and aligning that way, where would hybrids fall from that? So that's something to seriously consider and look at how that impacts things.
Okay, appreciate that. Thank you.
Thank you. Doug Carpa.
Yeah, Doug Kerpa, Peninsula Clean Energy. Yeah, I'm curious about your thinking around using ELCC across the board, also for thermal resources, because those are different values.
Mhm.
And it might be good to have a consistent approach.
Yeah, and that's our proposal too, is
Proposal
looking at
two, okay,
specifically
yeah.
that. Yeah,
I'm
absolutely.
I'm playing catch up still.
It's okay. Stephen, did you have a question on proposal 1 or comment?
Yeah, I'm just going to ask that the availability assessment for storage.
Mm-hmm.
I have some concerns with that. I mean, how exactly would that work, and wouldn't it be influenced by a number of other things that, I'm just thinking about how that would work, and I'm not sure that that's the best way to do storage.
Yeah, so it would work similar to how we might look at natural gas. And so proposed or talked about at the top some different definitions of at-risk hours, of looking at, just those net peak hours, the hours that we have loss of load in the model or in reality, and looking at different ways to assess that. There are some fundamental limits that energy storage can have because of the amount it can actually discharge. So that could create some challenges, but we'd appreciate input on how you guys think that would be best characterized if it does fall in an assessment of availability.
Yeah, I guess, I'm just thinking of some of the discussions we've had, like on VCR for storage.
Mm-hmm.
And, there's this, when you get to those later hours where they maybe had a day ahead schedule, but they may have, used up that energy in the middle of the day, so not be able to generate during the peak hours because of state of charge type stuff. And I'm trying to think through how that, what the implications are, either for reliability and for the storage resources, and how they count for RA.
Yeah, and we'd appreciate your thoughts on that specifically. That is one of the trade-offs that we have between proposals 1 and 2 to some degree. Is it's less computationally intensive, but we do miss out some of those interactive effects. And I think storage might be on the cusp for that.
Okay.
Yeah.
Thanks.
Right. Looking at proposal 2.
Sorry, Mark.
Oh,
we
sorry,
do
yeah.
have a question online from Mohan.
Go ahead, Mohan.
Yeah, this is Mohan, with CDWR. I had a question on the hydro resource being put under the ELCC resources bucket. But I think how hydro could be better situated would be, forecasting hydro generation availability based on the hydrology forecast. And I'm not sure if ELCC captures the variability of hydrology, for example, from annual to the monthly process where there may be significant changes. And I don't know if ELCC will capture the change in hydrology within the compliance here. So I'm just wondering why, how hydro resources could be having a better reflection based on the hydrology forecast versus ELCC calculations. Just thought about that.
Yeah, and again, we appreciate the input on that of how to best characterize it. Some of the challenge is how far in advance do we have a good hydrological forecast, and how we'd want to look at hydro, low, average, high, stochastic combination when we do those ELCCs, especially looking further out. So that's all stuff that we're considering, and appreciate thoughts and input on that as you have them.
Yeah, and thanks.
Here, thank you, Mohan. For proposal 2, this would be looking at average ELCCs for all resources. This is looking at taking the entire resource section of a portfolio that is calibrated at 0.1, removing all the solar resources, finding out how short we are, adding perfect resources until we're back to a 0.1, and then using the perfect resource that we needed, divided by the nominal capacity of the resource that was pulled out to get a percentage for the whole set of resources. A plus here is that resources are on a level playing field. The capacity should be interchangeable from one resource type to the next. The PRMs are predictable and primarily dependent on demand variability, not changes in the portfolio. And resource characteristics such as energy limits, outages are all accounted for in the model. Some challenges with this is the resource intensity to calculating this. How granular do we want to get with the ELCC groupings? Do we want to say it's all gas? Do we want to say CC? Do we want to say CC that's a 3-on-1? All specific, so we need to take some care with that. And we need to take care to make sure that the ELCC numbers that we produce work and the process works well with any kind of UCAP proposal that ends up being implemented. So we're not overly reducing capacity from resources or not creating something that's significantly different. So those are some of the things we're considering here. Any questions before I go to the third one?
Not seeing any at this time.
Sounds good. Proposal 3 would be the marginal ELCC based on critical hours. This is not us performing an ELCC assessment of each individual resource by adding capacity, pulling it out, but rather looking at the critical hours where any additional available capacity would have an improvement to our loss of load numbers, so decrease the total loss of load. Again, with just like proposal 2, this one places all resources on a level playing field. It may be a different playing field, but they're still being compared on a one-for-one basis, so they could be interchangeable. The qualifying capacity is directly related to the incremental value that the resources provide to improved reliability or worse reliability. And it's much less computationally intensive. This would require us to have basically a portfolio that's calibrated to a 0.1 LOLE, and we can calculate the marginal ELCCs to all the resources from there. The PRM developed with this method could lose effectiveness if folks aren't using a marginal ELCC qualifying capacity measure. Because you're looking at that marginal value, you're going to have lower ELCC values. You'll end up with lower PRMs than most other approaches. And so if somebody were to take, and this is the mix and match situation, if somebody were to take an exceedance value for solar and place it against our ELCC PRM, or marginal ELCC PRM, there could be some disconnect between the counting. So we'll need to take some care again with measuring this, or implementing this alongside of how UCAP was implemented to make sure we're not overhitting on specific resources and that those things make sense. And this, again, questions remain here about the interoperability of this approach with LRA programs. So we want to be careful that we're not creating confusion, we're not creating more or bigger challenges or different challenges, but that we're applying things in a way that's useful. Looking at proposal 4, which is a 24-hour monthly peak day stack, which would rely on exceedance values and derates and energy storage dispatch requirements to maximize the minimum PRM that we can reach with a reliable portfolio. This approach has us finding, that 0.1 LOLE portfolio, and then adding up predetermined qualifying capacity values based off of exceedance for those resources and using storage to maximize that PRM. What's nice about this approach is that we can predetermine what those qualifying capacity the qualifying capacity accounting rules are for resources. They don't have to be dependent on the portfolio itself. Storage gets shifted around a little bit, but ultimately we can say this is how we're accounting for it off the bat. The challenge with that is we need to look at this monthly. We expect to need to look at it monthly to make sure we're finding the months where the PRMs are going to be the tightest or where the minimum needs to hit. And so there is a need to look at the monthly. And then the contributions to reliability do vary by hour, by resource type. So we move from having 1 for an annual program or 12 points that we're looking at to looking at 24 times the annual number, 24 times each month. And so you are looking at more items as well. So those are the 4 proposals we're looking at. I'd be happy to pause for any questions or comments. Ansel?
Yeah, thanks, Mark. On this proposal 4, I just kind of wanted to add, we didn't hear, when I spoke this morning to stakeholder feedback and CAISO responses, we didn't hear from non-CPUC jurisdictional LSEs or the LRAs that there was a desire in the comments to adopt or reflect a default rule set that reflects slice of day. It's still something we can consider depending on additional feedback, but I think I just wanted to speak to why this wasn't indicated as kind of a preferred approach in your summary slide. We did hear about kind of, like I said, program interoperability with our processes, our RA processes at CAISO, but just wanted to clarify that.
Thank you, Ansel. Stephen, you have your tag up?
Yeah, I'm looking at the slide for marginal ELCC based. So this is number 3.
Mm-hmm.
And I'm realizing especially the comment less computationally intensive. I have some issues with that, but I think it's probably because I don't understand what it is you're doing. My thinking about it is trying to compute the marginal ELCCs. You're going to have to do that for every resource. To me, that seems like it would be a lot more computationally intense. And I'm thinking what that's indicating to me is that I don't understand what it is you're trying to do in that section. Can you please explain a little bit more how you would calculate the marginal ELCC for the units?
So this approach, Zachary Ming from E3 described in more detail in November. And what this would be is finding a resource mix that is a 0.1 LOLE. So you have that resource mix that hits our target. And then you add up you identify the critical hours that we need to look at. And so for this way, the graphic that we have here, the critical hours are really just the loss of load hours, where you have loss of load. And you add up the contribution of each resource type. So it'd be still looking at solar, not each individual resource. It wouldn't be a vintage-based marginal. You'd say, okay, all the solar resources are providing in total 100 megawatt hours of energy across these 3 or 4 or 5 hours where there's loss of load. And you add up the contribution of each resource class in that same way. Sorry, take a step back. So for solar, if they're providing 100 megawatt hours across those 5 hours, let's say, and there's 100 megawatts of solar on the system, so the ELCC from there would be, it's 100 megawatt hours divided by 5 hours, so 20 megawatts an hour on average, and then you divide that 20 megawatt hours by the installed capacity. So you're not looking at running a full ELCC study for each resource mix in a marginal way. You're adding up its average contribution during the critical hours and dividing that by its nameplate capacity. So a resource that could provide 100% of its capacity at all times would still end up with 100% marginal ELCC, but resources that contribute less, and even if more in 1 hour and less in another, you're looking at its average contribution across the critical hours. And so it's less computationally intensive, but it's a little bit different than the marginal ELCCs that have been done in the past.
Okay, that's what I was trying to understand. Then I have another, I don't know if it's an observation or a question, but when you look at this graph and you compare it to the chart, you're still going to do the PRM for the peak hour?
That's the current.
The new, you're looking at your loss of load hours now are, not the peak, they're after the peak. So I'm just wondering, I can't think through what that might mean.
Yeah, generally that means you're going to end up with lower PRMs, and depending on when those loss of hours happen, those PRMs can get really small compared to the peak. It works out because you're accrediting resources based off their contribution at the time that's critical, and so your resource need can essentially remain the same, but your PRMs get smaller when you're measuring at that peak load. And that's one of the reasons why we're hesitant to want to move forward with this one, is how does that make sense? Is that intuitive? It's not the most intuitive thing. It makes sense and it works out mathematically, but it's going to be hard for that to work with other approaches that LRAs could be using.
Okay.
Doug, Noah's pointing to you to go first.
Yeah, Doug Karpa, Peninsula Clean Energy, I think kind of a similar question, digging a little bit further in. So when we talk about the contribution of each resource type during this period that's like taken from actual production data, I'm guessing that starts to nudge us towards like some sort of exceedance, like we'd have to do some sort of exceedance methodology of like, we're looking at a bunch of different days and they're bouncing around. So we've got a whole swarm of solar contributions. And out of that, we're going to have to like take an average or the 70th percentile or whatever it happens to be. Is that?
So this approach would actually be simulation-based.
Oh, it's
So you'd be running those simulations. We'd run, say, 500 simulations. Again, we'd want to make sure we have enough hours that it's statistically significant.
Gotcha.
And then we'd sum up, so say there's 100 hours with loss of load, we'd sum up the contribution of all the resources during those 100 hours.
Where there was a loss.
Where there was a loss of load, and that would identify what that looks like.
Awesome.
Yeah.
Okay, great, thanks.
Absolutely.
That is also can be defined, that's user specific, right? You can define loss of load hours where LOL was observed or critical hours 5 p.m. to 9 p.m., whatever that is user defined, and it's simulation and output like Mark mentioned. So you could look at all the cases. You can also look at all the 500 cases or only the 50 cases that had loss of load. So it's very customizable on how you want to accredit these. So that's why it's less computation intensive, because you're looking at the outputs of cases already, but it's not in the traditional sense of marginal where you're looking at each half a megawatt in some ISOs do, or resource by resource of based on its COD. So. Yeah.
Noah?
Noah Tom from Middle River. My brain may have glitched. Would you agree, the difference between Proposal 1 and Proposal 2 is that the availability assessed resources are going ELCC than in Proposal 2, right? For all resources?
Correct.
Okay. So that means that, or can I make the assumption that you will get rid of RAIN under Proposal 2? Am I jumping to conclusions on a mat?
I'm not going to answer that one. I'm going to leave it to the folks working on RAIN, but I don't think that would be implied to necessarily happen.
Well, if it's, I don't think that would be implied. Well, then if it's not implied, then what's the difference in 2?
Between 1 and 2?
Yeah, I mean, well, I guess then how would you do RAIN on top of ELCC for Proposal 2? How was that question? There you go.
Mark, maybe I can help out here.
Yeah, let's go
Sure.
with the
No, I think, remember, these are setting the default counting rules. So they would, regardless of which choice we go with, they would, that's not what's going to happen in reality. What's going to happen in reality is PUC-based QC rules that are going to be applied in the operational perspective. So when we talk about RAIN would be tied to the NQC values and the RA values that are shown. That's how we would need to think about it.
Wait, yeah, no, this is where my brain glitched. So let's stick, before we get to what other LRAs do, and if the ISO here is considering 1 and 2, my question is, if we go with 2, do you then also get rid of RAIN?
We will tell you how we're going to deal with the RAIN tomorrow. Anya.
Sure, this is Anya. Well, we're going to get into a RAIN replacement tomorrow, and we have a new acronym, MURA, measuring unavailable RA. And the notion is that it's looking at availability based on the must offer. And so regardless of the QC approach selected, that you would still have a RAIN predecessor kind of applied.
So you would apply an availability incentive penalty structure to an average ELCC structure.
Yes.
I'll also add, and I'll talk about this kind of the current state of how we're thinking about it this afternoon. So the availability assessment in Proposal 1 could be UCAP, in some form for those resource types. And so, again, I'll talk about what Proposal 2 would look like if an LRA were to adopt average ELCC across the board, and how UCAP would or wouldn't fit into that. So, yeah, just stay tuned.
Yeah.
Thanks, Zach. Chris Devon, Terragen. I guess I would just point out that, again, these default rules have never really been used before. It seems like there's a lot of work associated with the modeling behind all this. So, you know, perhaps CAISO should consider a concept where there's a time frame that kind of triggers this rather than doing all this every single time. You know, because of a few reasons. One, there's the workload on your side. If no one is going to use these values, all of that work seems to be rather, you know, for no good reason, perhaps. The other part that's more concerning, I think, is having these values out there and then competing with the CPUC's slice a day values in this sense. I mean, we have to contract around what are these resources worth. If you have two different types of accreditation where you have the slice a day values that we're really doing the contracting around, and then what is CAISO's modeling showing would be applied under a default rule, that doesn't really bode very well for us as far as how do we actually decide how to contract with LSEs for our resources. So I think perhaps it would be best if, you know, whatever CAISO chooses of any of these proposals, that you consider an idea of like at, you know, some point during the year, maybe in April, May, I don't know, before, so you have some time before you get to the time frame when you actually have to do this, you know, NQC list, that you know, ask everybody that's at LRA to raise their hand and say, are you going to use the default rule this year? If so, we're going to go through this process and, you know, come up with the ELCC list or whatever it is, you know, the default NQC list, rather than having that posted every single year.
Okay, thank you for that comment. Brian, you have your tag up.
Yeah, thanks, Mark. Brian Thaker with Middle River. Just to avoid any doubt, under Proposal 2, the QC value, the ELCC value would include a resource's historical or outage performance, forced outage performance, correct?
It would be the modeled performance, but as we discussed earlier today, it would be based off of some of the historical aspects, correct?
Okay, so then any penalty applied to that for unavailability arguably would double count the outages. You would receive a QC value that's already adjusted for outage performance, and then you would receive a penalty for outage performance as it occurred.
I'll have to think about how that fits in, but I think that's something that we'd want to be careful around.
Okay, thank you.
Yeah, Ansel, do you have something to add there?
Just again, I think that will be entertained tomorrow in the RAIM replacement discussion. So yeah.
Stephen King.
I have another question on Proposal 3. You're looking at doing it on an annual basis, or would this be done on a monthly basis?
It would have the option to do both ways, potentially. Monthly is a little more work intensive than annually, but it is possible to do them both ways.
Okay, because I'm just looking at the way they're talking about it, the new LOLP hours differ greatly depending on what season you're talking about.
Correct.
July versus January, those hours might be very different. I'm just trying to think how that would work, trying to aggregate them into an annual thing.
You're absolutely right. It would change over the course of the year, and we have to be cautious about how we account for that with how we apply the rule.
All right, thanks.
But if Proposal 3 is the way to go, we should think about breaking the year down for sure, either to seasons or months, whatever is palatable. And going back to Chris's point earlier, I think slide 38 has that point where we say the last time QC was updated was in 2006 or first adopted, whenever, right? Many, many years ago. So now we are going to update it, but then we expect to review them periodically to see use, application, timeliness, need, and all that, and only worry about updating the defaults if necessary.
Yeah, and just to respond to that, I think, you know, when it was updated last time, that's like a one-time snapshot look, and you didn't have to do anything else after that, right? It's just been sitting there in the tariff.
Yeah.
So this approach is a lot more time and resource intensive if you guys actually do the analysis every single year. I'm not saying it's not a useful discussion. I think in the LOLE study, and we've asked for that, right? I mean, so there is a value to doing this analysis, but I'm saying that I think we would be concerned if CAISO is going to be posting a thing every single year that says, here's the value of resources. No one's using it really effectively. And then then there's another one that is effective, right? So that just overly complicates things and makes an additional layer of work that KAISO maybe doesn't necessarily need to do. If you have the default method that you've chosen and demonstrated in the tariff, then you could do that if somebody actually is going to use it. That's my whole point.
Thank you. Noah or Doug, I don't know who went up first.
Beat you to the draw. Yeah, let me think about it more. Chris, this is Noah from Middle Repair. Following up on what Chris is saying, I mean, I think it would be useful to have a list and the resulting PRMs for purposes of the ISO understanding when they are putting in all different types of apples from different LRA programs together to see whether or not something's reliable, that the system and the shown RA fleet is reliable. So again, I will say again that there needs to be a translation tool for that to happen. But without that, we are literally comparing apples and oranges, and it's really, to me, would be really difficult to figure out whether or not we have a reliable showing.
Do we have any online, or do you want to put Doug on the spot to see if you thought about it enough? I've presented my last slide, so I don't want to.
Oh, okay. Well, I'm happy to fill up space. So I don't know if that gets anybody anything. Yeah, no, I think following on those points, I keep a little bit coming back to the notion of, there is this idea that calculating it every year if nobody's using it's potentially an issue. I think coming up with PRMs that people are going to use if they're not using the accounting rules, also potentially an issue, as we talked about. And I kind of keep coming back to, it might be worth including heavily as a factor in decisions about what the default should be, trying to get it close or aligning with what people are actually going to use. Because if you do that, then the PRMs are going to more or less be aligned, which I think I said already. So I'm not sure what more to add to that. And I guess my following a little bit on that is my understanding that certainly all the CPC jurisdictional, like the huge chunk, are going to be using exceedance values. And I know other LRAs are maybe not crazy about slice of day, but those exceedance values seem to be, will be in common use probably beyond just the CPC, in which case they are now. In which case that seems like, maybe, number 4 is going to be best aligned with the actual industry practice in the state. I don't know if that's a solid argument, but that's kind of where my initial thinking's going. But isn't, Doug, that's undermined by the fact that LRAs use other LRAs exceedance QC values, but then choose an ISO default PRM, right? Again, comparing apples and oranges at the end of the day. So you need something that is standardized.
Oh, in a perfect world, yeah.
That's what they're trying to achieve, I thought.
But I thought the whole point, if you create a standard that nobody uses, it's not really standardized, right?
Yeah, agreed.
Yeah.
And so, but again, if everybody's coming in with their different ideas and numbers for their showings, how does to me, the purpose of this would then be, how do you ensure all those things get synced up and are talking about the same number or value to get to a point 1? Because otherwise, we know potentially all those other LRAs are not at point 1.
Yeah.
Right.
I think that, that's exactly the problem. I think Eric pointed that out, and we're all kind of aware that there's a synchrony problem, and we're not going to get around that. I think then it becomes, for me, it becomes a little bit of a bet hedging approach of you're not going to get everything apples to oranges, but can we at least aim at the largest basket, and we're going to call that apples, and everything else can be pears rather than oranges. And it's getting closer. We're not going to land on a analytically perfect 0.1 LOLE. It's a question of how far off we're going to be. We're going to be really, really far off, or just really far off, or maybe just far off. I don't know. Anyway.
I'd like to get closer. What? I would like to get closer.
We'd like to get closer, yeah. In which case, I would think you'd want to pick rules that give a PRM that is based on the practices that are most in use, which is a little bit like, instead of KAISO picking the default, you're letting the industry pick the default, which is probably not a comfortable spot to be, but it might be, and it's totally chasing a
a goose around the farmyard.
Well, but then what you're saying is that if the LRAs are fine at 0.3, that's it.
I don't know if fine's the word, but maybe the best. Yeah, I don't know. Like I say, more thinking to be done. If I come up with brilliant solutions, I'll let you know.
Please let us know. Comments now. With that, pardon.
I think we're really getting into a lot of those more complicated track issues that we'll discuss, like how can we form our various process procedures? How might these decisions factor into those areas? But to me, it's not an easy. Those aren't going to be easy discussions either. And so I don't we can't. We'll have those too, but I think right now we're really trying to want to make sure that these defaults are effective for that first step.
Mark?
Yes, Ansel.
I also wanted to add, on the comment of kind of the effort and workload that Chris was alluding to, just reminding folks that the underlying modeling updates will be able to be taken advantage of by the summer assessment because that is going to be using the same model. Is that right?
Largely the same model and updates. There may be slight differences in the resource mix that we include, but yes, there's duplication of effort, or not duplication of effort, but we're able to use that effort for multiple things. There's just more runs that we need to do to calculate ELCCs than if we didn't. Yeah. All right. With that, I'm going to pass it off to Aditya to talk about our next steps. Thank you.
Thanks, Mark. So what's happening right now? We are, like I mentioned earlier in the morning, we are updating the models to a new version of Plexus, new details and data in being done there. Making some other changes that will be exciting. Model will be publicly posted like always, so folks can go and look at it. It'll be more at the resource ID level going forward rather than PSP focused. So you can look at our stack model that is posted, the probabilistic model, all of that will be based on a list of resource by resource. Obviously, for confidentiality purposes, we are going aggregate average values and stuff like that. That is reasonably representative of that resource, but doesn't have the actual value that we have in other that the ISO has access to. We are also building a lot of automation tools to be able to process the data from these various output cases. So that is in motion. And then once we have all of this, we really would like your input and feedback on which proposal to lean towards. If you have a preference that way, obviously that doesn't mean it has to stay forever. It can change again. Next 2 years, we can come back and revisit after all of our RA process reforms have been more thoroughly discussed and formed. Then we can come back and update these values at that particular point in time as well. We're also looking for feedback and input on the frequency, if you have a preference for monthly PRMs, if you have preference for seasonal PRMs, for us to be thinking about it, that context. We'll be happy to put those things in motion. And then we'll take a break for a couple of months or so, and then come back with a full set of, here is what we heard, here are our default numbers based on this methodology, and then give one opportunity to refine before we call this effort kind of complete. And then we'll come back with the final proposal for the default rules at that point in time. So specifically from a feedback request standpoint, we only have 3 big questions. We've heard good feedback on improvements to modeling. I think we took care of everything except the weather-informed kind of weather-related correlation, which is in motion, that we are exploring what's the best thing to do, how to do, what tools are out there. So it might happen at a future point in time, but I think everything that at least I wrote down have been incorporated in the discussions that we did today. So anything else that we've slipped through the cracks is what I'd like to know in point one. The second question is feedback on QC accreditation and PRM proposals that we talked about. The three is any additional analysis if you would like us to perform before you can come up with a strong direction on which direction to move to. And fourth is any feedback that's not actually that's not captured in any of these questions that if you'd like to share, I'd be happy to have your input on all of these aspects. Hopefully this is a chicken and an egg and a preference problem. So all of those things have to be taken into account. Like Partha did earlier, it is we'd have to think about the different tracks in their full detailed discussions and how all of those fits together as it comes to default rules. So we can have a path forward for right now and then update these in 2-3 years when we have a better operational history on the reforms of RA process and procedures with the ISO. And I guess that's any questions. You can always reach out to me or anyone on my team or Partha and team. And this is a time for us to break for lunch. I'll pass it to Christina.
Thank you. Yeah, we'll be breaking for lunch now and return around 12:50. Oh, sorry, we do have one more question.
Sorry, I hate to, I'll try and keep it short. Listening to this and thinking about it, I think one question that I'm coming up with is the reason that we're coming up with these counting rules and the default PRM is so that when we get to like the track 3 on your backstop, basically that's where it becomes useful, is when you're trying to backstop, you're trying to make sure whether things are actually counted correctly. But the issue that we've broken that kind of connection, and there's two ways. One, just in terms of how we're talking about it, it's kind of broken, but it's also broken by the sense that you have these default rules and the default PRM, but they don't really, they have nothing to do with what gets looked at when you do your backstop calculations, because that depends on what the various LRAs have. And I think we may need to kind of consider that in a more holistic process and try and understand. Otherwise, when we get to that backstop, I mean, I have a lot of issues about how that's going to be done. And it involves things like, like this year, when you look at who's compliant and who isn't, who might be causing reliability issues and who might not. I question whether the data that you're getting has any, pretty much almost has any relevance to that, because the numbers, because of like the exceedance counting that's used for the BUC entities, and then also used by a number of other entities, that has different implications for the two different things. So I'm guessing most CPUC entities are, well above their PRM, just because they have to include all the resources, and so, their counting is very different. But I'm just trying to understand, I think one of the things we need to think about is how that concept kind of jives with what's in these default, what are we trying to do with the default PRMs? And I'm not sure that that's something that's really been discussed, and I think we may have to, and I'd kind of like to get to it maybe a little bit before we get to the backstop piece, because I think it's going to come up there, and I'm not sure how you're going to do backstop when everybody's compliant, but we're still short. And the modeling results that you showed, where if you use, when you looked at the 24 actual showings, you were showing you think that leads to a LOLE of greater than 0.3. I mean, that to me is somewhat concerning then. So, because I don't think you backstopped last year, but yet, according to your analysis here, we had LOLE of 0.3 or greater than 0.3. I'm just, that to me is something we need to, that should be discussed.
Thanks, Steve. This is Partha with the CAISO. I think you're raising up really valid, good points and things that we'll get to. I mean, I think that there aren't easy answers to these questions. And I think partly there's a number of moving parts, which I think we can just be blunt and acknowledge that, partly it's like we're trying to have processes and procedures that work with different LRA programs and different design rules that are sort of foundationally different at this point in time, particularly with the CPUC moving to slice of day and other LRAs, not necessarily adopting the slice of day design. So I think that when we get to the topics of like our backstop procedures, I think it's kind of an open question about like, how do we, it was sort of, I think, a foundational goal that we heard from a number of parties here, a lot of parties of wanting to sort of maintain that LR, not wanting to have the ISO having that centralized role and sort of dictating what the counting rules and what the showing process look like, giving deference to the LRAs. And I think that like once we get to that sort of the nuances of our different process and procedures, we wanted to make sure that, like there probably is an open question of does that simple stacking exercise that we're doing today continue to make sense given the diversity of resources, the need to sort of have these portfolios fit together in a comprehensive manner, or do we need to have some other procedure in order to sort of square these? I think this will come up as well in our outage substitution processes in terms of, I think that the topic was kind of raised of like, do we need to have sort of a holistic look? Do we need to have like for like substitution? A bunch of options were sort of coming up in that, which have a similar type of vein of how do you put together these different LRA programs within our process and procedures in a manner that sort of still makes sense, but also sort of allows for those LRAs programs to work effectively on their own. So we're certainly taking that seriously, and we'll certainly get into that in that backstop discussion. But I think that part of the reason why we're staggering them in this manner was that we recognize the fact that those will be probably much longer conversations in terms of how to square those things together. But yeah, I appreciate your raising this, Steve.
Not seeing any further questions, so I guess we will break for lunch and return at around 12:55. Thank you. Hi everyone, welcome back. We're returning from the lunch break, and we're going to be beginning the discussion with Ansel, who will be reviewing accounting for ambient derates.
Oh, I
This
see.
should work now.
There we go. Okay. All right. Thanks, Christina. So I'm Ansel Lundberg, and yes, we will be getting into this afternoon talking about straw proposal leanings, again, after we heard from stakeholders in December, kind of about the approach that we should take as we develop the straw proposal in the next few months. We will be starting with the track 1 policy elements this afternoon, and then going again into tracks 2 and 3 tomorrow. So this afternoon I'll be sharing kind of, we've narrowed some of the options and trying to signal some direction that we're thinking for the straw proposal on these 2 items, as well as, again, some of the more detailed pros and cons. And so I'm looking to kind of facilitate more discussion this afternoon about what stakeholders are interested in and what direction, if the direction we're taking based on your feedback makes sense, and additional questions you might have going into the straw proposal. So I just said everything that was on these 2 additional bullets, so thank you. Okay, so just to review a little bit more in depth for the track 1 elements, we have, of course, modeling, which we discussed in depth this morning, the latest for our probabilistic and deterministic modeling, which will be used to inform the tariff default counting rules and TRM that Mark touched on this morning. And the goal is to demonstrate a framework that could achieve a 0.1 LOLE. And then this afternoon, we'll be talking more specifically about UCAP And the goal of that, of course, is to ensure supply resources are available when they're needed based on their forced outage and ambient derate, historic or expected resource data. And then I put capability testing in quotes here. That was the title in the issue paper. I think we're potentially moving away from that framing, but accounting for ambient derates due to temperature during peak load conditions. I would also like to make a note on the slide numbers. They may begin to deviate from the deck that is on the website, and you can blame me for that. So please, if you have questions, just make sure to note the slide numbers in this live presentation. That will be the best approach, I think, for that. So I believe that should not impact tomorrow's presentation, but just a disclaimer. So at this time, I'll take a moment to just share kind of the big picture as far as the concepts that we're thinking about for the straw proposal for track 1 for the policy elements, including the default counting rules in PRM. So top line is we intend to continue to partner with the CPUC and other LRAs in this process with the goal of ensuring that appropriate resource adequacy capacity is procured and shown by LSEs. And as we discussed this morning, the default counting rules and default PRM in our tariff should stand alone as a holistic accreditation scheme. I use this phrase off the shelves. So we talked about, you know, if an LRA so chooses, they should be able to adopt our default rules in a way that allows them to utilize those as a planning tool. And if implemented, would achieve that 0.1 LOLE. And then sort of separately, but in an integrated way, sort of with CPUC's UCAP proposal and alignment in mind, we are considering a UCAP derate through the CAISO NQC process, which would be applied unless RA resources are accredited using an LRA's performance or probabilistic QC methodology. For example, also, if an LRA were to adopt our default rules. So there's a little nuance here with proposal 1 that Mark covered this morning, which kind of is more of a combined approach where UCAP would be the default rules potentially, or whatever the expected availability would be in that proposal 1. So there's kind of some different options or ways we could approach this. So we're looking to get feedback on this. And then this is just kind of a graphic representation of that. So again, the default rules should be provided as a tool for LRAs to adopt if they so desire. And those are based, of course, on our robust probabilistic modeling with transparent inputs and assumptions that represent best available information. And then UCAP and accounting for ambient derates, which we'll talk about in a moment, is a way to account for force outages through the NQC process if they're not already accounted for in an LRA's QC methodology. So this might be familiar in the previous straw proposals at CAISO a few years ago. There was kind of a similar approach. It's a little bit different, but this is how we're thinking about it right now. So interested in feedback on this. I do want to, I should mention also a similar approach with ambient derate. So accounting for capabilities during peak conditions as a part of our NQC process, as we've discussed in the issue paper. So I want to pause there. You know what, actually, let's just run through so that's kind of the big picture on track 1, how we're thinking about it right now. This is a little bit more about each specific element. So on the default rules in particular, this morning, kind of different options we could take. I think something I would like input on, which will be detailed more in the straw proposal, is kind of how the updates work. We talked about kind of the frequency of the updates and how necessary that is. But tariff language, you know, it might require CAISO to issue model runs and values, but it might not have, we could issue the values and model runs as a separate process instead of having to update the tariff every time. I think that could make sense. So that is still to be discussed. On UCAP, again, an additional element of our NQC process to reduce values based on resources forced outage rates. We're thinking about that in the style of the supply cushion UCAP, which we detailed in the issue paper, where you look at each resource's forced outage rate during a portion of kind of the tightest hours of the year. I'll get more into that later on the details of what that actually means. And ambient derates, we're thinking, we got some good feedback in the comments on the November workshop and in December, and I'll start with the second bullet there. It says testing-oriented program would be resource intensive. So we're kind of trying to think about how we can achieve the results and the goals of this effort to capture resources capabilities during peak conditions in a way that is not a significant implementation burden for CAISO. So again, more on that in a moment, but we're moving towards a more kind of data-driven approach in this first bullet, kind of looking at peak load conditions and then look at ambient derates due to temperature during those times and modify the NQC value based on that. So again, big summary here. We'll get into more details of kind of what this means in a moment. But before the next section is more on the ambient derates proposal, but I would pause there and kind of I'd be happy to take kind of big picture questions or thoughts. And I guess anything else from the team up front that you'd like to add on this? Okay, looking good.
I'm not seeing any questions online at this time or in the room.
Okay, I think more detail will be helpful. So jumping into the ambient derates thought, and so again, just to frame all this, we're calling this straw proposal leanings or options. So we're narrowing our options that we had in the issue paper. We'll be fleshing out the straw proposal in the coming months. So just kind of trying to give a snapshot of where we are based on the feedback we've received on these items and further refine today. So no, go ahead.
No, Tom from Mineral Power. Can you go back once? Sorry, I don't know how many slides.
To the previous, yes.
Sort of going from point to point here, default counting rules, to the extent the ISO, I'm going to focus on proposal 1 and 2, being either ELCC or potentially UCAP, between those two. However, then under your bullets of UCAP, applies a derate to resources that do not receive a QC value from an LRA derived from a probabilistic or a UCAP, you're going to apply another UCAP? Or is it, are you applying, so then does that mean that you're ruling out proposal 2 altogether?
So thank you for asking for the clarification. It's a little bit, I see where you're coming from here. The idea here is if we went with proposal 2 for the defaults,
which is ELCC.
Yeah, average ELCC for every resource class, that would mean that the NQC UCAP derate would not apply additionally on top of the average ELCC, because the consideration would be that the outage rates are already factored into the modeling that is used to produce the average ELCC values. Does that help?
Yeah, I think my confusion
Yeah.
is simply if someone or if an LRA
Yeah.
does not have ELCC or UCAP,
Yeah.
then here it's saying that the ISO will then apply UCAP on top of,
right,
which is sort of cart before the horse of the ISO not going to put ELCC under proposal 2 for these types of resources.
If I may, so in this sub-bullet, and then, yeah, or go ahead, Partha, yeah.
And maybe when you say the cart for the horse, to understand, like, when we're talking about that, we're talking about the default, not like a minimum, not a requirement. And so, like, if somebody did adopt that and said, hey, I want to use the default, let's just say that we went with that option 2, it's applying it for everyone, and they said, yes, I want to adopt an ELCC value that's being applied to all resources types in my program. But we're not, I think to me, that could be for one scenario. What we're really talking about here is, like, they still can say, like, no, I don't want to choose any of these default options, and they might have something for
PMAX.
Yeah, a PMAX, and then we'd say, like, that's a scenario, and we're saying we'd apply it.
Yeah, I guess what I'm interpreting this should say is, in case if an LRA chooses to use PMAX, the bullet under here should generally mean, like, the ISO defaults it to. No, wait, no, that doesn't make sense either. It seems like if an LRA says it's PMAX, then you're saying, no, we're going to apply UCAP, even if UCAP is not the default. That's weird.
So, yeah, this sub bullet under the third bullet is what you clarified. So, if our default rules under, say, proposal 2, average ELCC for everything, were applied, then there would be no need to apply the NQC UCAP, because the available or the historic rates would be incorporated into the model that produces the ELCCs. And this is kind of how we're thinking about it right now. So feedback is helpful and welcome.
We also have a question from Rahul.
Hi, this is Rahul with AES. This may be obvious to everyone. I'm coming in late. Is this discussion only applies to modeling that CAISO is doing to understand how much supply is in the system, or this is to the RA program that everybody in the state has? So, for example, if we as an IPP have a contract with an entity that's in an LRA that just follows CAISO's default rule, and if they do not have the ELCC, they just use PMAX or just follow CAISO rules, UCAP will now be applied to that. And the current rule is there is no CAISO NQC for, or they have to request an NQC when RA is sold. That's when the UCAP will be applied. So that's the new paradigm we are talking about.
Yes.
Which
that is matches with this characterization. Yeah.
So there will be very well defined rules and sections that explain that these things are changing. Okay, thank you.
Okay. If there are no other questions right now, again, we're going to get into some more detail here, so let's do that. Okay. So, accounting for ambient derates, as I mentioned in the issue paper, this section was titled Capability Testing for RA Resources. We got some helpful feedback from stakeholders on this. Some other ISOs and RTOs take a more testing-oriented approach. It matches well with their RA programs, and we also looked at a few other RA programs that did not use a testing-based approach and looked at more of a data-driven approach, more similar to a UCAP consideration where it's not oriented around testing, but you can look at historic resource performance to understand how these resources perform in peak conditions. So with that said, I think in the straw proposal, we're thinking about moving in that direction as well and away from the testing-based approach. So the idea would be that there's an additional step to the NQC process where CAISO would examine recent peak load conditions and review ambient derates for RA resources due to temperature during these conditions, and then derate the RA resources NQC values in some manner based on this analysis. So again, I covered the capability testing. We had good feedback from WPTF and CalCCA about kind of more of this data-driven approach as opposed to the testing-based approach, and we think it makes sense. So there are questions still outstanding about kind of how that would actually work. So WPTF had a suggestion related to how to characterize what are historic peak load conditions. So one way would be to look at the maximum energy output of these resources, of our resources in the prior 3 years on the top 10 peak load days. And there would be, the question would be, I think there's an outstanding question of, in other markets, with a more testing-based approach, that may reduce a resources must offer obligation, because if you're thinking about, okay, we're trying to capture the capability of these resources, with a UCAP D rate, you still want RA resources to be bidding at their maximum capability, but a D rate comes later through the accreditation process. Whereas when you're looking at ambient D rates in peak conditions, you're trying to recognize what is the maximum possible output that these resources could have when they're needed. So I don't have any leanings on this last bullet, but would love to kind of hear thoughts or considerations on this, on these ideas, and as we develop the straw proposal. So this is the only slide I have on ambient D rate accounting. So yeah.
We have a hand raised by Eric.
Yes.
Eric Little, CalCCA, and not going back on this should be based upon actual statistics, but just a couple questions on how you deal with some things.
Yes.
If in that prior 3-year period, if they didn't actually receive a dispatch order to be that high, what do we do then? Right, their bid keeps them out of the money because just the conditions were such that you didn't pick them up, the model didn't pick them up.
That is an example of some of the ways that this approach may not capture kind of what a resource's capability is. Whereas the testing approach is more, with a test, you can confirm or rule out that a resource is able to achieve a certain performance. But if you're just looking at historic performance, then the case you mentioned, if it didn't receive a dispatch to maximum, then we wouldn't have the information through that to apply the appropriate reduction. So
okay,
yeah.
So maybe there's a base it on history, but leave some opportunity for testing in certain circumstances. Because the other one that I could think of is, suppose somebody goes through and does a bunch of work on their cooling systems, and their ambient D rate is not as bad as it was before, right? They wouldn't have gotten picked up last year that way because they couldn't dispatch that way. They did the repairs during the winter time. Now they can. Seems like you could test them to see if they work that way as soon as summer gets there and be able to give them that uprated capacity. So I think maybe it needs to be a combination of both. You probably capture 99% of the world through historical and really only have to leave that 1% exceptional type of thing that happens for the rest of it. Thanks.
Thank you, Eric.
Rahul with AES. Can you explain what does the bullet point implication of must offer obligation imply from?
Yeah. So to put a finer point on that, again, in this question of how do we account for ambient D rates in peak conditions, the goal of this policy change would be to ensure that a resource is not accredited for a higher value than it's able to produce during times of need. Whereas, a UCAP approach might be, okay, what is the actual historic performance over time? So there's a slight distinction there. It's very slight, right? But this is more looking at, okay, if a resource is called on, can it perform to Pmax, or can it perform to something lower than that in that moment when it's needed? So the must offer obligation, I raised that because in the issue paper we talked about what other ISOs and RTOs do. Some of them who have a more testing-based approach, if a resource can only test to a certain condition or is adjusted performance during peak conditions, then the idea in those markets is, okay, the must-offer obligation of that resource should be reduced accordingly because it's capturing the capability of the resource. Whereas with UCAP, there's more of an incentive system. You still want resources to perform at their maximum capabilities, which may be higher than the UCAP factor. But so I think the question here is, okay, if we have this data-driven approach, would it mean that there, I'm looking for stakeholder thoughts on kind of if must-offer should be matching that or not. So go ahead, Martha.
No, that sounds right on. I think one of the examples that will come up tomorrow will be with respect to like performance and availability incentives. And so like in our new proposal, that's kind of one of the key questions is kind of like what is sort of the must-offer obligation that we're measuring performance against off of, and that like as Angela described, in general, we'd expect like some types of derates are really just based upon the variability of the resources and the expected reliability contributions given that variability. For ambient, it's a little different, and so I think we're teeing up the question of what's that appropriate measurement in terms of what that move. And one of the examples is for our revised RAIM design. So
yeah, maybe I can add.
Sure.
The way I would think about this is, my must-offer obligation should match whatever RA I'm allowed to sell. But what I offer in the market should be what is my Pmax, because I might be able to generate more during an emergency condition if just I was rated lower. So I would tie that to, must-offer obligation is tied to my RA obligation, whatever RA I'm allowed to offer based on all the rules. So yeah, that's my feedback.
Thank you.
We have a few questions online. First from Mark.
Hi, folks. It's Mark Smith of Calpine. First of all, I agree that the must-offer obligation should be tied to what you're able to sell, which is often NQC, not PMAX. But not always. Sometimes we don't sell all the way to the top of our NQC. So somehow or other, the must-offer obligation has to be tied to what you actually have committed to or sold in the market. But more generally, I think since 2009, and if you look at our combined cycle NQC values, you'll see that Calpine does already shape those combined cycle units specifically for ambient conditions. So you'll see August values substantially below January values. Those are based really on thermodynamic characteristics of expected ambient temperature and humidity in that particular area. So I think there are ways to estimate, what an ambient D rate would be instead of just looking at the historical data that might have all kinds of anomalies embedded within it. So maybe we should look at, more theoretical calculations. Of course, ambient D rates aren't the same for a whole month. They aren't even the same for 1 hour or for all of 24 hours within a day. There are times during, for instance, the peak ambient temperature where we might have a lower output, but by the time you get to net peak, which is probably more important to the ISO, temperatures have dropped and your ambient D rates are lower. So it's a very complicated topic, and I would just advise you that looking at historical data will embed anomalies that could be misleading. Thanks.
Thanks for your comment, Mark. Noted that.
Next, we have a question from Paul.
Hi, this is Paul Nelson with the California Public Utilities Commission. Can people hear me okay?
Yes.
Yes.
So this is capacity values are going to generally apply to a 1 and 2 load forecast. So for the ambient temperature D rates, is there any thought to calibrating or adjusting observed values to a weather normalized year so that they're consistent?
Yeah, thanks, Paul. That is an approach that is often used in the testing-oriented programs in other RTOs, which is kind of a, actually to Mark's comment, you can take an approach where you have kind of a hybrid, where you have using the generator's tested capability curve, you can adjust for peak conditions, you can adjust the testing data, if that makes sense. So it could be incorporated.
Okay.
Next, we have a question from Bonnie.
Hi, this is Bonnie Blair. I work with the Six Cities group. On the topic of aligning the MOO or not aligning the MOO with the NQC values, I don't see how a must offer obligation can exceed expected capability to produce, because bidding above or submitting a bid above expected capability to produce, if I'm not mistaken, is a market conduct violation. In other words, you're offering something to the market that you don't really expect to be able to produce. So I think that there has to be some recognition that, you know, that the MOO shouldn't exceed actual production capability. And I don't know whether that's picked up in the outage reporting system or not. In other words, you know, if your MOO obligation is 100 and because of system conditions, you think you can only actually provide 95, are you supposed to report the missing 5? Or are you supposed to bid it, and even though you know you can't produce it?
Thanks, Bonnie. Go ahead.
This is Abdul. Bonnie, you're supposed to offer your must offer obligation. Generally speaking, there's unique scenarios for different resources, but the generic kind of must offer obligation in the BPM is to offer all of your RA capacity that is available, and available means not on outage. So if you expect your resource to have unavailability for some of the megawatts or all of them, then that you report that through an outage, and then you complement that with your bidding behavior. So that's just existing must offer obligation rules. I don't think ANSOL is proposing changes to that. I think what kind of to clarify the kind of discussion about must offer obligation implications are if we would adopt such ambient derate process to the resources, that would potentially impact their final NQC value. Their NQC value is how much the max RA they can show. And that means their must offer obligation would go down with that NQC value going down. And that's probably what we're thinking to hear back, feedback on. We're getting something by perhaps reflecting the NQC of the resources, a more accurate reflection, but then at the same time, we might be losing some of that must offer obligation based on, to Mark's comment, based on, maybe the peak hour is when the resource cannot, offer all that amount, but maybe the net peak hour they can. And now, but now they don't have a potentially must offer obligation to bid it even in the net peak hour for the value that they can do. So that's a discussion I think we were trying to hope to hear back from you guys on kind of pros and cons and what we're gaining versus what we're losing from such ambient assessment.
Thanks, Abdul. Yeah, I'll just add, I think, Bonnie, you kind of captured the problem statement of this policy. Is what you described is what we want to make sure isn't happening. And so how can we change the NQC process to account for that? So
We had a hand raised by Eric, then Noah.
Eric Little, Cal CCA. We need to think about the way that we want to measure this. So I can give you an example right now of someone who is expected to have a must-offer obligation that is higher than their qualified capacity. Anything that's measured by ELCC. Their must-offer obligation is whatever the forecast is, right? So there we say, I know that the resource is not going to be at its Pmax. I know it's probably not going to be at its Pmin. It's going to be at something in between those. What it's going to be on any given day, I don't exactly know. So we derate them for counting purposes to make sure that we buy more of them, but we also make them offer their full amount. So the question here is, are we treating this like that, or are we treating this in a more scientific manner that says something on the order of, I know that for every degree above 90, I lose 1 megawatt, right? And it's much more a mechanical type of a situation that I am guaranteed of, and then you don't lose anything by saying your must-offer obligation is, well, it's 5 degrees above 90, so it's 5 megawatts below your Pmax. So I think more thought needs to be put into exactly how we're going to measure this to get to that. To me, that's where the heart of the problem is, because I'm kind of, as I hear comments, I'm kind of hearing both sides of that. And I think if you put it together and really think about it, that's what we're dealing with, is how certain are we versus how much is this more like an ELCC?
Thank you.
Noah?
Similar to Eric, I was going to ask if whether or not outside of renewables, we currently have any type of accreditation that leads to a higher MOO in the ISO's current world. Hydro? Well, I mean, we
higher than the NQC.
I'm sorry?
Higher than the NQC.
Correct. Right. Eric provided sort of for renewables, wind and solar. I get that, but they don't have an actual bid insertion, I guess, and therefore must offer obligation. But are there any other resources that we currently have where we sort of derate the QC value, but then leads to a higher hourly bidding structure?
I would have to take that back.
Yeah,
Anything from the team?
I don't recall
Okay.
any such. Other than the VERS, I don't recall another example of.
The only thing I was thinking is hydro, but I don't know if that's true.
Even hydro's must offer obligation is to the RA value that they show us. But I guess Run of River Hydro offers everything they can based on that day's forecast.
But the bid insertion in cyber is not
There's no
associated.
bid insertion for them.
Right.
Yeah.
So which means that
Bid insertion is always up to the RA value. We don't insert bids. I don't recall a bid
Correct.
insertion beyond the RA value.
Correct. So, if you're similar to what Eric was saying, in your LLE studies, if you're expecting a 100 megawatt resource to perform with certain amounts of forced outage rates and so forth, but you give it a 90 megawatt QC value, then should you be only requiring a 90 megawatt MOO, and knowing that sort of the 100 megawatt MOO results in a 90 megawatt QC value for accreditation purposes?
Yeah, and maybe this is how I think about it. Love to hear feedback. Like, to me, like things like you're talking about like a UCAP derate or something that sort of derates their availability. Probably what you're doing is you're really capturing the variability. So if you were just sort of saying, I'm going to cap them at this, like let's say the UCAP value. Let's say a hypothetical resource that was 100 megawatts, and I'll give a big derate for ease. Like say it's a derate of 50. Well, if the MOO is at 50, because 50% of the time is at 0 and 50% of the time is at 100, then, and you really were just sort of capturing that their MOO at 50, well then still 50% of the time they're at 0, and now 50% of the time when they're available, their must offer obligation would now be at 50 megawatts, so it'd be even less valuable resource. So to me, for things like a UCAP calculation, you still want to have the must offer obligation sort of at that that higher value does not reflecting the sort of the variability within their counting methodology. Are we on the same page? Yeah.
Yeah, I understand that.
We also have a hand raised by Michaela, and then we'll go to Rahul.
Sorry, Michaela Fox, yes. So I thought with other markets that use UCAP, they don't typically tie the must offer to the UCAP amount. I know that some determine the ICAP by the test, by some sort of testing, and it should be ambient adjusted. And then it's not even based on just always ICAP. Like if you only sold half of your UCAP for RA purposes, then your must offer is 50% of your ICAP. So I feel like it's kind of been figured out. Not figured out, but like I think it's a common issue amongst RTOs.
Right.
Okay.
Maybe ask a question of which ones, like when I think about the application of UCAP in their market is really sort of what's the basis of their, for me, like, there's probably a bunch of implications, but like they do their pay for performance calculations based on the UCAP value. And so how well you're performing to the whole is a sort of comparison of your UCAP accredited value to your actual performance during those reserve shortage events.
But then sometimes the must offer is even different from that. Like your must offer can be different from what you're even expected or what your like pay for performance like expectation might be. And then, but it also kind of depends on like what like the must offer expectations in terms of like what RAIN will look like, whether or not there are like financial implications to meeting it or not. Obviously, it's an important expectation, but I think how accurate we want to be with it really kind of depends on what constructs around it financially and operationally exist. But yeah, that's a good point, is that the what even ICAP means in other markets.
We had Rahul, and then we can go to Eric.
Before you go, Rahul, I just want to add one thing. So another thing to consider here is what I presented here would only be examining ambient derates due to temperature, which is one nature of work. So that would inherently, only certain resource types are subject to that nature of work. So just something to consider.
Yeah, hi, this is Rahul with AES. I was going down the same path that it would be ideal to first figure out which resource class this discussion is applicable to. Right, the question that I heard about, what resources have a must offer obligation that's maybe not consistent or aligns with their offering. Use limited resources always have a must offer obligation, but they do not, because of their very nature of use limit, it's possible they don't get dispatched and they don't get penalized. So there are these various combinations of scenarios where there is an implication for what we're talking about here. So maybe for future, when we talk about this, it'll be really important to figure out what resource class are we talking about, right? And I don't know if we are thinking of ambient derate even for ELCC resources. My assumption would be no, but it would be good to know, get clarification that this is only for non-ELCC resources.
I've made a note of that. Thank you. I think just to your first comment, I don't have a pros and cons section on this slide, but I think that any of these mechanisms, the more data-driven kind of expected method versus testing is going to be a little more optimistic, if I can say that. It might be a little less fine grained. It's going to miss some things perhaps depending on what load days we look at and whether or not a resource was dispatched, as Eric was mentioning. So just recognizing that. Yeah.
We had Eric.
Eric Little, CalCCA. So I think you were onto it with what are the consequences?
Yeah.
Right? So let's just take an extreme example. We go to UCAP and RA aim is gone. There's no financial penalties. Then if you have a must-offer obligation that is the Pmax of the resource, but it can only operate 5 megawatts below that, the only thing that's doing is it's on a forced outage because of ambient due to temperature. That's just reinforcing for your next 3-year period what that number looks like, right? There is no financial penalty. You got the full amount offered to you that you were going to be able to get. Then you really have to work into the, okay, well, now what if we have some sort of a financial mechanism in there? Where does the financial mechanism now take hold? Is it at the full must offer, or is it at or below the amount that I actually expect them to produce from an RA standpoint? So I really like that idea. Thanks. I think it was Michaela who kind of was mentioning that. So I think that's probably really the way to look at it.
Next, we have Perry and then Noah.
Perry Servideo, CISA. I wanted to sort of echo what Eric was saying a little bit earlier about how it's more easy to see what the MOO is for a resource that's on ELCC because there's a model behind it that incorporates some kind of outage rate. And then therefore that means that if the resource were over the course of the year fully offering itself, then randomly you would get this outage, which then eventually results in this sort of ELCC value. But it sort of assumes you have the whole resource available to you. That reinforces the idea that the MOO should actually be on the full resource. But I think that's applicable both to ambient derate and to, say, a UCAP. But the question would be for Aditya, is there a separate outage field in the modeling for the ambient derates, and it's accounted for?
Noah?
Yeah, we have that discussed on slide 31.
Okay, gotcha.
Where ambient derates will be its own derate, whether or not used. But then you have planned outages that get scheduled throughout the year, and then forced outage based on historical performance. And then there are some other things that we are not worried about, like the outside management control even.
Sure. Okay. Thanks for that clarification. And then to the other point about that's good to think about is if and I think this is where Noah was going, if the resource is only half sold as RA. It's not that it is that half of its UCAP is sold, but really what it means is that half of the whole resource is sold. So 100 megawatt resource with a 80 megawatt UCAP sold 40 megawatts of RA. Well, you're selling half of your RA, but that should make 50 megawatts of the resource available to CAISO in order for the 40 to mean something to CAISO. And I wanted to understand if that was your thinking on that as well, because you could have an instance where a resource is, say, sold outside of California for half of it and half of it's committed to California. And you wouldn't want, you actually can't consider half of the resources committed to CAISO with a must offer in that instance.
Yeah. Just again, kind of going back to the problem statement guiding this, I'm going to take that question back, but my initial reaction is, if the idea of this ambient derate accounting is make sure that it's something that acts like a cap essentially on the NQC value and all the implications that has. If a resource is only half sold into the CAISO BA, then that wouldn't have an implication because it's only expected to be, it's only half represented in the RA program, if that makes sense. So, but I think I'm going to take that back also.
Yeah, the question is then what portion of the resource has the MOO versus what counted for RA, and that's where it's getting to this sort of ratio idea that I've seen used elsewhere. But,
yeah.
Noah?
Yeah, Noah Tom from Middle River. I want to continue what Rahul was saying, but with regards to the must offer, I don't think it's only applicable under ambient derate. I think it's applicable to all performance-based capacity accreditation in the sense of ELCC and other forms of UCAP as well, right? Like anything that derates it from an ICAP mechanism, you would have implications on the MOO.
Steve Keen from Edison.
Sorry, I did not mean to I'm trying to get a
You need a clarification, or?
I'm trying to get a discussion on whether or not this is an agreement or not. I don't want to move on about from this particular point. Mike, sorry.
Based on what I'm thinking, if your ELCC, your ambient derates, all of those would have been accounted for within the ELCC itself.
Right, but then the question is if ELCC is 90% and you're a 100 megawatt resource, and what is your must offer if you sold 90 megawatts of ELCC? Is it 100?
So maybe I'll try to make clarification of how I understand things. For renewable resources, I don't think there is an obligation to deliver up to whatever is their offering, right? Like, as we said, it's expected that they always generate as capable. Their requirement is actually to follow the DOT when they're curtailed, not the other way around. I don't think a solar resource has an obligation to generate at forecast, right? And it's the idea is it has to offer. Whenever they have an outage, that may be subject to RAIM depending on day ahead or real time. So I think the paradigm is very different when you look at different resource class. That's why I made a comment that it would be good to attach a resource class to this discussion. Then you can only focus on those resource class and figure out what's the impact. So that's where I was coming from.
Got it. What I heard, I think that Ansel agreed to was sort of under the ambient derates aspect that the must offer obligation implications would only be applicable to ambient, and I don't think that's the case for thermal resources, batteries, what have you. And I think I just want to get let the record show the ISO is nodding its head, collective head. I don't know.
I agree fully. No, I understand.
You can interpret nodding as listening and or.
It's a good clarification.
Silence agreement, I think that's what it is. But yeah, I mean, it's important to know whether anything that goes away from ICAP for other types of resources that are not renewables, you will have this must offer obligation implication. And we have to design the system around that. And so the core question to what Eric was saying is, if you're a 90 megawatt or 90% accreditation to a 100 megawatt resource, and you're sold 90 megawatts, what's your must offer? And I've been under the impression that it should be 100. I think very similar to what Eric was thinking. But if that's not the case, and it sounds like other folks do not believe that's the case, then we should really talk about it. Because that is the core design of the RA program itself.
And no, I think that's also the exact question that we're asking as well. Mm-hmm. That's what that last bullet means. Discuss applications that must offer. That's what we want to hear back. Should we apply the must offer at the 90, or should we apply at the 100 in your example? I think if you guys recall when we first talked about UCAP years ago, we were thinking of doing UCAP as a cap for, and a cut to NQC that limits how much RA can be shown, but the deliverable qualifying capacity value would be the must offer, which would be higher than the UCAP value. Now we're talking about ambient derates, so that's an potential additional cut. Do we apply a similar concept where we limit how much RA they can show to the ambient derate cut, UCAP cut, but then the must offer obligation value is potentially a higher value? Or do we limit everything, keep everything together, including the must offer value? So I think this has been a great discussion. Yes. We want to hear what you guys think before we figure out what a good proposal would be.
And in any case, I'm hearing it would be helpful to kind of explicitly chart out these relationships and the ratios and the connections between each of these elements in this raw proposal. So, yeah.
Next, we had Stephen, then Rahul, and then Doug.
Steve Keen from Edison. I think, to me, part of this gets to something I think we're going to get to later with UCAP, and that is because we have a monthly RA obligation here. You go back east and they're like annual or seasonal. So they come up with, when they're talking about an ambient derate in the summer, it's a different thing than we're talking about here, because some of the resources here, they sell RA on a monthly basis. So they may be a 100 megawatt resource. In the winter, they may sell 100 megawatts because they can do it. But when they get to the summer, it depends what they're going to sell. Are they selling 100 megawatts and then taking an ambient derate outage for, the 10 megawatts, in which case their move should be 100 and they should get penalized for being short. But what if they realize that they're going to have an ambient derate, so they only sell 90 megawatts worth in those summer months? Well, then their move should be 90. And, this gets back to when you're looking at the UCAP obligation, trying to calculate UCAP and figuring out how much outage to assign them. What do you do for outages that they took by not being an RA, by not being an RA resource, by specifically planning their outage to happen, the month that they're not being RA? Does that count towards their UCAP or not? And it's a question that I don't necessarily have the answer to, but I think we need to fold that in, and I think that's where I think some of this discussion is going. It's a combination of how are they treating this outage. So like with ambient derate, if you're saying, well, we're going to count them as a 100 megawatt resource, and then they're going to have to take an ambient outage, okay. That gives them one thing. Then they have a must offer obligation to 100, and when you do your when you stick bids in for them, you're going to have to check what they have on outage before you go put the bid in. But they may just take care of that outside of the market and say, hey, we don't want to get dinged by rain or something else. We know we can't deliver 100 in those summer months, at least most of the time, so we're only going to sell 90.
Steve, can I ask you, do you have any specific feedback about the seasonal element, or because, CAISO's NQC list is monthly, and so any thoughts on that for this application?
No, I haven't thought it through. I mean, I've thought it through enough to realize that I think there's an implication here for that, but I haven't thought through to figure out what would be a decent solution.
Yeah. Sure.
This is Perry at CISA. No, just to this, sorry to jump in, but to this point about, say they only sold 90 because they knew they may be having an ambient derate that month and they don't want to get dinged. I think that's applicable to say the rain conversation. I don't think it's as applicable here, because you'd say, let them say the MOO is 100 megawatts. And if they had ambient derates, well, that's what we expected anyway, but you have to be bidding all of it, and then you can take your ambient derates, and then your tracking forward of the ambient derate factor year over year over year is not impacted by that sort of phenomena. Where you get into the tricky situation is then if you're going to also ding them in rain, now you're sending an incentive to say, well, now I'm going to make sure I'm going to lower my RA value because I'm trying to lower my MOO because I don't want to get dinged by rain. That's where, to me, where the complication comes, but not necessarily just in this context of the ambient derate and the UCAP.
Rahul, did you still have your hand up?
I just have one more, follow up on that. Not this specific topic, but when we're talking of ambient derate and must offer obligation, I think when you go to straw proposal, it'll be really good to go under what specific categories we are talking about, because the example that comes to my mind is use limited resource. A use limited resource has a must offer obligation, but it may not get RAIM in certain hours just by the use limited nature. So if I have a thermal assets with limited starts, if I am a hydro with limited, hydro generation capable, daily energy limits, all of those things create a different subclass in every class. So when we talk about ambient derates, must offer obligation, it's really important to note those variations. And also in the straw proposal, it'll be good to know in which paradigm. Like right now we are in the RAIM paradigm. If you move from RAIM paradigm to an incentive-based paradigm, the behavior and expected outcomes would also be different for different resource classes. So, I'm easily getting confused in different scenarios. So when we have the straw proposal written, it'll be really good to take those into consideration.
Yeah, and I'm not going to jump the gun for tomorrow's conversation, but I think what we're really going to be getting into is like the the need for understanding different resources, capabilities, and what the master offer obligation should look like from them, or at least how it should be, how performance for the accreditation to the sort of ultimate consequences for not performance was sort of fit together by resource type. And so I think we are sort of, we've gone through this a lot internally, but I think that what I'd really love feedback on, or maybe a preview in advance, is that I think we're really going to need a lot of stakeholder feedback of how different resource types are different and how it should be applied differently to those types. Because I don't think we're going to be able to go through just on our own and say, like, here's all the different resource types and all the exceptions. We're trying to create something that's as standardized as possible while also recognizing that the complications that you're bringing up are material for different resources.
We have time for Doug, and then we'll have to continue on in the interest of time.
Okay, I'm Doug Carpa. Eric Little, Cal CCA. I think I want us to think about the feedback loop on this. If we're going to use the maximum energy output from the prior 3 years, then if I'm a 100 megawatt resource with 90 megawatts of UCAP because of a 10 megawatt derate, is the only way that I ever go higher than 90 is to have uninstructed imbalance energy? Is that the only way that I get there? To go higher, right. That's what I'm trying to understand is if we're going to vary this every 3 years, but we don't give them the opportunity to come back up, then we're really capping that, and it's only going to continue to come down over time. So whatever the offer obligation is, we need to consider that in there as well. And if the answer is they have uninstructed imbalance, or they bid more than their capacity into the market and the market clears it and they actually generate, fine. But I want to make sure that whatever that must offer obligation is doesn't limit them from moving that amount back up again.
Thank you, Eric. Yeah, I think that goes to what Abdul and Michaela were discussing earlier about kind of ICAP matching with must offer in other markets. And then the UCAP is applied to accreditation, but you want the resource, like you're saying, to be able to bid and perform over the UCAP if it can. Okay. Well, thank you, everyone. This has been a great discussion. Got some great feedback. We are now on our original schedule, seeing as it is 2. So I think we can take an hour now to go through the UCAP section, and then we will break and have a few stakeholder presentations before we wrap up. So with the framing I shared immediately after lunch, I want to get into more detail about UCAP as we're thinking about it now as a part of the NQC process. So I shared this slide in December, just summarizing some of the stakeholder feedback that we received after the issue paper. This was very helpful in kind of informing where we're going for this raw proposal. There were many comments asking for coordination with the CPUC and supporting a resource-specific UCAP framework. And then there were numerous comments about various other elements of the design. So with all of these in mind, I'm going to share here sort of where we're thinking about for this raw proposal for UCAP. So just make sure I have my notes here. I wanted to also note that tomorrow, Anya will be covering a helpful incentive mechanism and UCAP crossover review, which will hopefully kind of help you understand how we're thinking about the new incentive mechanism RAMA form that we're considering with this UCAP consideration. That doesn't mean you can't ask questions, but we will have more for you tomorrow. So based again on feedback that we received on the issue paper, this is how we're thinking about how a UCAP could look as a part of CAISO's NQC process. So a resource-specific UCAP that is calculated as part of our net qualifying capacity process with a data source for forced outage rates being the CAISO OMS, outage management system, the natures of work that would be considered under CAISO UCAP are still to be determined, and we have a slide to cover that. We got some feedback on the supply cushion approach detailed in the issue paper versus E4D, which is used in some other markets. Right now, we're thinking about looking at the 20% tightest hours of supply cushion hours for each season across the BAA, and noting that E4D can be somewhat challenging due to the fact that NERC GADS does not produce the data that we would need for that for storage resources. So that's the explanation for that leaning. And then resource types was mentioned for ambient derate accounting. So from the UCAP perspective, this goes back to the summary slide at the beginning of my section after lunch, saying that resource types that have not received a probabilistic or performance-based QC methodology from an LRA would be subject to this UCAP. So that is meant to encompass other UCAP mechanisms that LRAs might have, as well as probabilistic, so ELCC methods, including CAISO default rules, as well as exceedance. And overall, we are seeking to implement a UCAP mechanism that meets reliability goals for CAISO and our LRA reliability partners. So we're seeking feedback from the local regulatory authorities on this as well. You know, I wanted to note, I don't have a slide on the CPUC, and there is a UCAP proposal from the Energy Division that will be discussed later this week at the CPUC. I just wanted to note that CAISO is continuing to collaborate with the CPUC, which is something we've heard frequently from stakeholders. We are supportive of the general direction of the Energy Division's UCAP proposal. We will continue to coordinate, as I mentioned, to refine that proposal. And we are working, of course, with you, all stakeholders. We do not have a proposal yet. We're moving in that direction to recognize that many elements of the UCAP proposal from the Energy Division align with kind of what we're hearing from you all as our stakeholders. So I can pause there. Each of these kind of has a little bit more in the future slides that I dive into some of the details here. I also have on the next slide kind of an overview of supply cushion UCAP if you didn't read all 7 pages of that section of the issue paper. So, but we can pause here, and I see we have a hand on the phone and take a few questions.
Yes, first we have a hand raised by Carrie, and then we can go to Perry in the room afterwards.
Hi, this is Carrie Bentley with the Western Power Trading Forum. I had 2 questions, a general one and then a specific one on this slide. The first one was related, you said you didn't have a CPUC slide, so I'm just going to ask this now, but if it's not the right time, I could ask it later. And that's just, can you talk a little bit more about the relationship between your mechanism, which is directly on kind of NQC qualification, I would say, and the CPUC, which is a counting rule. My assumption is you wouldn't do it both ways. And so the CAISO and CPUC are coordinating on whether you guys are going to apply it to all resources as a qualification type mechanism, or whether the CPUC alone is going to do it. Can you speak to that?
Yeah, thanks, Carrie. So I'm going to click back here. This is the risk of this approach. So on this slide, in that sub-bullet of the 3rd bullet, I wrote, you know, it would be applied unless RA resources are accredited via an LRA's QC methodology for accounting, which accounts for performance or probabilistic methods. So the idea is, under this framework, if resources received a UCAP-based QC methodology from the CPUC, then we would not apply UCAP through the NQC process at CAISO. That being said, we have heard from stakeholders, contract considerations, a desire for consistency, which explains our desire to kind of make sure that the two methods are aligned, continue to collaborate on data source and other design considerations. So, Partha, do you have something?
Yeah, just what you said was right on. I was going to build off. Our ultimate objective is to really have a consistent UCAP applied between between all the different LRAs within our area. And I think really it's a question of like who has the ultimate control of it. And what we're really doing is providing a mechanism that really allows for the LRAs to say, like, if we don't agree with your solution, we have the ability and a part of that tariff process to create our own values. But what we're really looking at for during this process is for a good, robust discussion, so we don't have that outcome where everybody can get to the table and say, yeah, we really agree that this one methodology is the right way to do it, and we can apply it consistently through all the different processes, including those other LRAs within that framework.
Next, we have Perry.
I think Perry had a second question.
Oh, yeah, and maybe a quick follow-up to that, which is just a quick point, which is that to me, it makes a big difference whether this is replacing a counting rule or whether it's some sort of mechanism that the CAISO is going to apply. Because if you guys file something in your tariff, you have a very strong onus to be non-discriminatory among resource types. And so applying your own kind of qualifying capacity on a set of resource types, to me, carries a lot of FERC risk. So that to me would be a key consideration in your design. Whereas if the CPUC or other LRAs want to do a counting rule, they're free to be as discriminatory as they want. Discriminatory not in a negative way, just meaning you are discriminating amongst resource types. So to me, that's a key consideration here. And then second, I'm so sorry to ask this. So you're doing the 20% tightest hours. And I just can't remember. Did you guys do a sensitivity on this where you looked at the 10% tightest hours and the 30% tightest hours and you decided 20% was the best, or maybe you decided it didn't make much of a difference? I just can't remember.
Great question. You're in for a treat. We have those later in the slides.
Okay,
So,
I must have read it in the slides then. Sorry, it's been a long week for me. All right, thank you so much.
You are welcome. And Partha?
Yeah, at least to get and Ansel, please jump in. On the discriminatory question, I think what we're looking to do is really have this being applied where there is, our UCAP values would really be applied to all resources that don't have basically a haircut already being taken by the LRA. And so that's really sort of that criteria. It's not really a resource, it's not like we're choosing resource types per se as much as that. And I think what we recognize is that most of them have something via ELCC, exceedance, or some other mechanism for most of the types of resources. I think that's one of the discussions we're going to need to have as well.
Yeah.
Going forward.
Kind of what qualifies.
What qualifies.
Yeah.
Because I think our goal is to have, we're trying to respect the deference to the LRA programs, but at the same time allow for us to have this information to be applied by LRAs who are wanting to use this within their program design.
Thanks, Partha.
Perry?
Hey, this is Perry Servideo, CISA. Just on that, I have a different question, but just on that last discussion, kind of have my head spinning a little bit on something that we've talked about before, and that's the relationship between the PRM and the UCAP and where you're taking that hit. So you could end up in a very confusing place where your defaults for one and the other are aligned, but based on one LRA giving you a UCAP value and another following your default, you may end up in a weird situation where your default PRM is not aligned with their accreditation methodology. I'm wondering if you all have thought about that before I get to my question about the slide.
We've heard from other stakeholders as well about this. I think it's something that needs to be considered. So, Partha, did you have anything else? Yeah.
Okay.
I was just going to say, we touched that this morning in the modeling discussion. It's a valid point. That could happen. Keep in mind, Perry, the limits, LRAs have jurisdiction over choosing the counting rules and the PRM. We can present a default that makes sense, and that's what we're trying to do with the update. But at the end of the day, it's up to them to decide what's the appropriate PRM and QCs to choose, and your scenario could potentially happen.
Yeah, it gets weird. I wouldn't want it to end up in a spot where CAISO is not getting the capacity that it needs to get to perform its BAA functions. So glad you all are thinking about that. My question is on the second set of bullets on this slide, and really it's the point that you're making between what you're calling E4D and your supply cushion hours. These are both actually E4D methodologies. It's just the difference between how you're defining the D in the E4D. So to just say E4D is difficult, it's like you're really saying you'd prefer to do the D in the first way where you use the supply cushion hours. But I was wondering if you could expand a little bit more on first of what you're thinking E4D would be in the second bullet, if not supply cushion, and what's actually so difficult about that. I heard you mention GADs, but as part of this and part of what the CPUC is proposing, we'd go just to using CAISO OMS data. So I'm wondering what remains difficult about this other E4D methodology.
So that's a good point about it's still an effective forced outage rate based on some kind of demand comparison. So I understand that. So E4D, there is a value in NERC's GADS database that is produced and is labeled E4D by a certain mechanism that they use. And my understanding is that it's not it does not capture storage resources for that particular field in the database. So I guess I left off a term on that second bullet, which would be a resource-specific E4D in the same vein would be something that we would have to calculate CAISO to produce that. And there's, when I say E4D in that bullet, I'm speaking of the kind of counterfactual E4D, which would be when a resource would have been dispatched by the market historically had it not been on forced outage. So, open to other considerations or methods, but.
No, that's helpful. I think we'll talk about it later this afternoon whenever we get into it. It's just helpful to clarify the bullet on the slide that you are thinking that this would have to entail some kind of actual counterfactual. It's been implemented in other ways in other ISOs where you don't actually need that level of difficulty to get a good enough value.
Okay.
Next up, we have Stephen, then Eric, then Noah.
Hi, Steve Keen, Edison. I want to go back to the discussion on the sequencing of this, especially between the different LRAs. And I want to make sure I'm understanding, and because I think there's issues. The CPUC is likely to have the numbers that they give you for QCs incorporate the UCAP. The other ones may not. So then you would have to ask the other LRAs, did you do some kind of a UCAP?
Yeah.
And did I hear you say you would set some kind of rules that they would have to meet in order for that accounting to count? And if they didn't, then you would apply a UCAP after the fact.
That is what the implication of that is. In our tariff, it speaks of LRAs submit a QC methodology to CAISO. I think what that effectively looks like is that they submit updated QC values to us. And so we would want to work with LRAs to understand what their methodology is and go from there. So.
But then I guess I thought when you did the net QC, the only thing you were supposed to be looking at was like transmission. You took the numbers from the LRA and made sure that they actually had, I guess it's deliverability is the term.
Yeah.
I'm just wondering how Obviously, since I work for an entity that's CPUC jurisdictional, I kind of like the idea of you stepping up and doing that, but I'm just wondering, I don't know that the other entities are going to, you know, we've already said specifically, you've already said that you can't do you're doing default counting rules and PRM. You're not, because you can't mandate them. But this is kind of looking like it's it's maybe a step beyond that.
Yeah, I think you're right. I think that what we're open to discussing here is taking that initial step. My understanding is that for most LRAs, they do some sort of haircut, either on their own. And so what we're really doing here is throughout the idea of what we could do is say, like, if they don't have any sort of process to reflect availability based on some sort of probabilistic performance-based analysis, then our UCAP would be doing the haircut, would do some of that haircut. To your earlier point, I do think that there's now kind of an open option where, like, depending upon how this is developed, different LRAs could just say, like, hey, we're going to opt into this as a part of our design choice and our process. We're doing this more, like, this is our initial thinking around this. We'd love to get feedback from other LRAs if this is workable for them in terms of their program design, but we wanted to have this out there as sort of a first step to, to get their feedback. If they, if we got a strong pushback for some reason, we really want to consider that going forward in our proposal.
The other thing I'd add is the other side of that, right, is the planning reserve margin. So if we proceeded with this approach, an LRA could make a respective adjustment to their PRM to remove a portion of the PRM so that they would be accounting for forced outages in the counting rules and not in the PRM. That makes sense. Depending on how they construct their PRM.
Thanks. I was just trying to make sure my understanding on this was.
Next up, we have Eric, then we'll go to Noah, then Perry, then Carrie.
Eric Little, CalCCA. Just a simple question. How many QC methodologies is the ISO getting right now? How many QC methodologies is the ISO getting right now? I see the NQC list, which has one number for each resource, which implies that they're getting one QC methodology. Because otherwise you would have potentially one resource having two different NQCs.
So we don't get methodologies, we get QC numbers from LRAs. I don't remember on top of my head, but there is probably 3 or 4 LRAs that provide QC values. PUC provides it for the entire non-dispatchable fleet. The other LRAs, 2 or 3, provide it for specific resources that they have a methodology and calculate QC for those. Our tariff directs us to, when we get 2 QC numbers for the same month, for the same resource from different LRAs, 2 or more, then the tariff says we would pick the highest value, the highest QC value for that month across all the LRAs, and that's how we do it. So we still end up with, when we build the QC list, we will always end up with a single monthly QC value.
Okay, thank you.
Next up, we have Noah.
Noah Tom from Middleware Power. 2 questions. Do you recall whether or not the PUC's UCAP proposal includes this 20% tightest hours?
I don't. Can I defer to Kevin? Or
Yeah, hey everyone, Kevin Head from the ISO. I am control Fing the number 20 in their proposal.
Wow.
And no,
It does.
No,
So
just to confirm
it does.
what I already knew, which was that yes, it does. Yeah.
Got it. Thanks. Also, between proposal 1 and proposal 2, with proposal 1 being UCAP here and proposal 2 just being ELCC running ELCCs, which is an easier option for the ISO as far as resources and such goes?
Thanks, Noah. I can't give a good implementation answer. We could take that back, but anything to add?
I guess to understand your question, Noah, so that proposal one that was for a modeling method that would be adopted as a default QC. Is that what, so that's the initial, so that one would be done regardless of what we do in UCAP cuts. the modeling process will always adopt a default QC methodology, and produce it and update our tariff with it. That's going to happen regardless of this, right?
No, your decision point between proposal 1 and proposal 2 simply lies with the mechanics of how UCAP is implemented, right?
No, they're not tied. So
What?
So
Wait,
you-
so you're gonna if you go with proposal 1,
yeah.
you're not saying that you're gonna have a different UCAP methodology to calculate those values for purposes of the LOE study. You're going to implement whatever you're gonna decide here with these, right?
Whatever we agree together here on a UCAP approach for assessing the performance of resources, that we will implement and add to the NQC process. That will do regardless of what default QC we adopt.
Okay.
Yeah.
But in a world where proposal 2 is alive,
Yeah.
You don't have to do UCAP
Oh,
at
okay.
all.
I see your question. In a world where proposal 2 is adopted, the average ELCC, and that is the method that is selected by the LRAs for establishing QC, in that world, we would not need to apply UCAP because all the resources now are calculated based on average ELCC. But there's a big if there, which is LRAs adopting it as their own or deferring to us to use it. See what I'm saying?
I want to go back to the words you used. If we're in world 2, proposal 2, not world 2, multiverse, types of multiverse. The proposal number 2 with marginal average ELCC for all resources, and an LRA, an LRA says, hey, I don't like that. Now you're coming in with, and I want to continue with ICAP. What you're saying is that, no, you're not going to get your ICAP. We're going to cut you to some methodology. So I'm still trying to figure out whether or not that's a UCAP methodology or that's an ELCC methodology.
UCAP. UCAP would
Why
cut.
not ELCC? Because that's applicable to your default and that's applicable to your LOE study. Because you don't have a study, you won't have a study for your PRM that's applicable to UCAP.
We won't have a study. It's in proposal 1, I think.
2.
No,
We're in world 2.
2, yes. 2 would not, but it's a big if, Noah. The if is people using, by people meaning LRAs, using average ELCC. Just because it's in our default tariff doesn't mean they're going to do it. You see what I'm saying? UCAP here would say, for those who do not adopt a probabilistic based or performance based QC, if you just come in and say, I'm just going to do PMAX, that's my methodology, we're not going to say anything. We're going to, okay, that's fine, but we're still going to subject to deliverability checks, and we're going to apply this performance based, forced outage performance based check, which is we're calling UCAP.
Okay. I will ask again, if we're in average ELCC land for all resources for the default QC value and the LOE study process, and an LRA says, I don't like that, I'm going to use ICAP. Why is the decision point for the ISO immediately to go to, I'm going to cut you to UCAP and not I'm going to cut you to ELCC, which is what the default is?
Oh, because ELCC is a default QC methodology, which we can only use if the LRA doesn't adopt its own. This UCAP mechanism is a performance-based cut to the NQC value, which we can apply on top of the QC value. Do you see the difference?
Here's the question. Like, I think you're asking that foundational question. We'd want maybe it's good for other LRAs to speak up and to get into voice our ideas. You're just saying that we still hope that would sort of fit together comprehensively with whatever they're doing to set their PRMs and to set the counting rules for other resources. So we're presenting one option would be, hey, we could have this be applied as a UCAP-based, haircut based on our calculations and the supply cushion methodology, but you're just saying you should still work well with all the other values. So if it is the case that they're using ELCC for all other values, but then somehow have had an ICAP for a certain resource type, then you're saying, why, like, shouldn't you go back and just apply it in a consistent manner? So it might be good just to get a feel from other LRAs how that would be best applied in their programs, on a consistent basis. Because you still want to provide this as an input, and then they can use to have a program design that works well for their LRA.
Yeah, I mean, I think I would be more comfortable if you were to say, if the LRA comes back with ICAP, then we shall, the ISO shall use a methodology that is performance-based or statistically based, rather than simply saying we're going directly to UCAP. To me, if ELCC is simpler for the ISO to run, then if we go down that path, we can sort of ignore. Don't have to talk about this particular topic. I understand that you might want to talk about if we go through proposal 1.
Next, we have Perry, and then we'll go to Carrie, and then to Doug.
Yep, no, that was a great segue, kind of follow-on question. I'm going to simplify the question. I'm just going to say that if CAISO's default QC methodology is ELCC, then I'm to assume you've used a forced outage rate in your PRM calculation in the study that determines PRM. If the CAISO uses a UCAP default, then your PRM will not have the forced outage in the study that calculates the PRM.
This is Mark with the CAISO. So if we are using the average ELCC, the forced outages are accounted for in the QC side of things, not directly in the PRM. So it's accounted for in there for sure. It's in there, but it wouldn't necessarily be something we'd say, hey, 7% of the PRM is forced outages. It would be units are derated to an ELCC value because they have forced outages. So same thing with UCAP. If UCAP would be the resources, and UCAP would be unit specific rather than resource type, which the average ELCCs would be resource type, not unit specific. So there's a little bit of a difference between the two. But that UCAP would be derating the resource based off of its outages as well, but it wouldn't necessarily have the interactive effects that you capture in the ELCC.
So you'd account for it in the quantity within the model, but not then model a forced outage rate on it.
We would model the forced outage rate for getting that ELCC value. The forced outage rate would be captured in the model, but it would be for everything's average ELCC, the qualifying capacity would take into account the forced outage rate. The PRM itself could be calculated purely from variation in demand and what reserves you need. You wouldn't need to add forced outages into the PRM directly because it's accounted for in the QC.
Right. You just want to keep those in their own buckets, I guess, is the point. And then I also wanted to make the point then, if you do develop as a default QC methodology in ELCC, applied across resources, I still think we'd like to see alignment on the calculation of the forced outage rate that you use in your model. It's just as important as us talking about the second set of bullets here of what is the methodology you're going to use to define that D rate. So I'd still want to see the conversation and that methodology drawn up and specific, even though it becomes the input into the model rather than just the haircut on the ICAP. And it'd be good to see that alignment with however the LRAs do it or however the CPUC do it.
Sorry, I'm not tying back to these bullets great in my head. Could you just talk about that for a little bit more? You're wanting alignment in the forced outages that we use in the model versus what would be used in the UCAP. Is that what I'm hearing?
If you were doing an ELCC method, then there's not a UCAP method, right? Okay. But the calculation of the forced outage rate that you're going to use in the model that determines the ELCC and the PRM, that calculation method is still important. And we'd still want to see that stakeholdered, not just, here's how we did some general method and came up with 5% derate or whatever. That's the point. It's just as important to us as whether we do it on the UCAP side or whether we do it in the input model side, that we want to see that forced outage rate methodology stakeholdered.
Thanks for clarifying.
Next, we have Carrie Bentley online.
This is Carrie Bentley with the Western Power Trading Forum. I think your responses have been really helpful. I think I just want to state on the record, WPTF's view is we think this is crazy. You're talking about having a slice of day mechanism, 2 potential UCAP mechanisms, one by the CPUC, one by the CAISO, and then other LRA probability or mechanisms, and maybe ELCC on top of that for our default rules. Like, this is why people hate bilateral RA programs. Like, that's too much. That's way too much. I mean, I'm not even sure what you're getting out of this, because if another LRA, let's say the CPUC does their own, they want to use the 50 tightest hours, so their UCAP is way higher, you're going to go out and say, okay, that's fine. And another LRA, if they want to keep doing what they're doing, they just have to come up with some sort of mechanism that'll pass that test, right? Because otherwise, if you're saying that they have to be at least as restrictive as this UCAP mechanism, well, now you basically just have backdoor QC rules, which definitely wouldn't be okay under your program. And they wouldn't align with the PRMs by the different LRAs. So I'm failing to see what the point of this proposal is, and just really caution against adding all this additional complication. We have huge affordability issues, in part because of the complication and lack of transparency in the RA program. And I think anything that makes it more complicated should be weighed very heavily against the risk to affordability.
I've noted your comment, Carrie. Thank you.
Yeah, good. Can I engage you for a second? Is Carrie's still on the line?
Yeah, I'm here.
I think your feedback on the complication is something that we are well aware of, and that there's been sort of a significant conversations about sort of how do we partner well with the PUC in their evolving program design, work well with other LRAs in developing effective rules, allow for deference and differences within our program designs and structures, but also move the ball forward effectively towards better, more effective rules given our current challenges. And so, yeah, I'd love to engage with you. Love to hear more about sort of what your thinking is around. We recognize that this is very complex, and this will add significant complexity to our processes. What's the more simplified design that that reduces complexity is, I think, something that we struggle with while sort of meeting those competing objectives. So love to hear more from you now, but it also could be in your comments around what that looks like.
I'll just briefly say, I think everything should come up against the test of what will you get from this? So if the CPUC does UCAP, what will you get from this? I would argue effectively nothing. So I would think the CAISO's efforts would be better spent to coordinate with the CPUC and move this into their process and make sure they adopt a UCAP mechanism that you guys are comfortable with. And if we want to design it here and then move it over, that's great. But I think duplicative UCAP mechanisms should be inherently off the table, because if your goal is to move the ball forward, I don't think this does it, not toward efficiency, certainly.
Yeah, we say duplicative. I do think that we're probably maybe that's the key point. I think we really are looking towards our objective being consistent designs between the PUC and other, the PUC, whatever's in the ISO's processes, and other LRAs. I think that's really the question, sort of procedurally, how do we get there, and what are the implications if we don't get there? And so I think that you're probably raising a fair question of, if the PUC ultimately had a different design than what we had, would there still be a value add to us creating this process, or will we be better served just working within the confines of the PUC processes? But yeah, right now I think what we're shooting for is that North Star where they're all where it's aligned and consistent, and where we have stakeholder feedback from the other LRAs of, yeah, this works well with our programs too. But it's just a matter of how do we get there, And then I think you're asking a fair question about, like, what are the implications if we don't? Does it still make sense for us to move forward? And I think that's a really a good question that we'll have to work with stakeholders on. But any thoughts on that, Carrie?
If I may, yeah, just a small clarification. I am not focusing on rule or program alignment because inherently theirs is a QC rule that will exist within the slice of day construct, and yours is a rule that you're applying to a peak program. And those are two inherently different methodologies with two different objectives. And there's no way to perfectly align them. Even the resource types you would apply them to are different. And so I'm saying I don't think you should move forward with this at all within your own tariff. Even if you manage somehow to have a perfect UCAP that made sense both under slice of day and a peak program, which I don't believe is technically possible, but let's pretend it is, I would still say don't pull it into your own tariff. All it is a backdoor QC program that has inherent FERC risk to it that is pretty wild. I'm pretty sure our protest would say this is a backdoor QC process and doesn't make any sense. I just think your efforts would be better spent in other areas.
A quick question, Carrie. Thanks for the feedback, by the way. So if we have resources that are today getting their QC at or close to their PMAX, there is no performance-based methodology. There's no historic, essentially based methodology. They're essentially getting their nameplate. How do we assess, or how do we assign them an NQC value that better reflects their performance-based capability, a realistic NQC value instead of essentially a nameplate value, which is the intent of NQC?
The intent of NQC, I would argue, under the CAISO's tariff is certainly not performance-based, and I wouldn't call UCAP performance-based either. I would call it historic availability-based, and you do not have that tariff authority right now. WPTF has long advocated for you to take that to demonstrate to FERC that LRAs are not, providing sufficient capacity needed for a balancing area to have a 0.1 loss of load expectation reliability. We fully support the CAISO moving forward with that sort of program. But unfortunately, your tariff does give deference to the LRAs, and doing this sort of overlapping backdoor program for a tiny portion of your LRAs, I don't think gets you what you want, especially because they could just come up with their own probabilistic counting rule that will override this proposal anyway. Because you're not making this a minimum, you're just saying, if you don't have one, this applies. So I would say if you want to take a swing at it, you could put in, default rules and say, if you don't live up to holistically a 0.1 LOLE, well, then our rules apply. There are lots of different ways to slice and dice it. I just don't think this is the way.
Okay, so I think we would love to hear your feedback, Carrie, on maybe an alternative on how to achieve that goal that I mentioned. How do we kind of get more realistic NQC value for those resources than what we have today? I think that's the intent. If we can get that somehow, then we achieve the goal, whether it's UCAP or another way. So, you don't have to answer right now. If you want to think about it, put it in a comment. Either way, I think that's what we're trying to do here.
I'm afraid I think my comment will be currently that's not your job. The CEC has a proceeding on that, right? For the non-CPUC jurisdictionals, they've looked into this. The CPUC has it for their jurisdictionals. Right now, you just don't have that in your tariff authority, and that's just not the intent of your RA program. If you want to set a minimum reliability standard, then we would support that. But I think it's a little disingenuous to say that, you want to move toward a performance-based NQC, because that's not really what you want. What you want is better reliability. You want LRAs to provide you more capacity and a more complete RA program. I'll stop talking now. I apologize. I've taken up a lot of time, but I think that's the goal, right? A reliable CAISO balancing area, and not this incremental movement for a small portion of LRAs. Thanks.
last hand up we have is Doug, and then we should probably continue on in the interest of time.
Yeah, Doug Carpa, Peninsula Clean Energy. No, a lot to chew on there, for sure. I guess I would express a certain amount of appreciation for the notion of incorporating. Fundamentally, I think the issue here is there are a set of resources that do have outages that are not currently captured, right? And that's a problem. And I think in particular, Peninsula Clean Energy, part of the reason we're here is because we're a very renewables heavy LSC. And one of the consistent issues that gives us a little bit of heartburn is that if we have a system where one set of resources, namely gas, have outages that are currently captured in the PRM, we are bearing the cost of those outages, even if we are not contracting with them. And it's that cost shift between LSEs that have very heavy renewable portfolios and onto us, and away from those that have very gas heavy portfolios. That's, I think, why we look at this and think like, when looking at slice of day, that's an exceedance methodology, right? It's look at what you're doing year in, year out, day after day, take a look at that whole distribution, and from that, get an exceedance value that captures that variability and accounts for the fact that you're not always there all the time, right? That's inherent with renewables. UCAP, to my mind, is a kind of an exceedance methodology, and essentially, so coming from the CPUC world and slice of day, we're all like in exceedance. To me, it feels a very natural analog to have UCAP as you could even just call it exceedance, right? We're going to take a 70% exceedance value for gas. We could do that, right? And that's, that's roughly what UCAP is. So I guess I would express a certain level of comfort with this approach because it gets closer, as we were saying earlier, it's the apples to pears, not apples to oranges. And yes, pears and apples are in the same biological family, and oranges are citrus, they're further out. So I like the approach, exploring this direction. And thumbs up. Watermelon's a whole other thing. I think they're cucurbits or something. I'll have to look that up. Anyway.
Thank you, Doug. Yeah, I think looking at kind of the problem statement that we're trying to address is a helpful practice here. I'd also kind of, we've invited stakeholders here today to talk about policy development. Some of these things, visibility tomorrow we'll be talking about. We're recommending no tariff change will be necessary. Some of these things we anticipated tariff change will be necessary. So there's a world of options on the table as far as the future. So that's right. All right. So as Christina mentioned, we have about 15 or so minutes left in the hour. I'm just going to use this time perhaps to run through some of the intricacies of the UCAP design that we're thinking about. And I also have those promised numbers related to the different supply cushion levels. I also have a preview of the supply cushion hours. So, Doug, do you have a quick comment here?
Very quick comment.
Yes.
On the other thing about having, is there any prospect of having like a joint CPUC CAISO stakeholder process? I mean, yes. Okay. No, would never do that. What are you talking about? Okay. For UCAP to get like agreement or like, hey, this is our joint proposal. Anyway. Just thought. A lot of collaboration. Yeah.
That is the word of the day. There is not such a proposal, but thanks, Doug. So just to quickly run through this, so when I say supply cushion, and we talked at a very high level about this in November, but what the supply cushion is a way to look at each hour of the year and assess how tight the hour is in terms of supply versus demand from the RA perspective. And so what that looks like specifically is a value that is produced by looking at shown RA for that hour. So when I say that hour, this is a look back. It's to produce an expected value. So minus wind and solar resource adequacy resources, planned and forced outage impacts, net real-time average load for the hour, averaged across the 12 5-minute intervals, and then an additional 6% contingency reserve. So when you get that number, it shows you how tight the hour is for what RA you have versus what you can expect to be needed. And the intent of supply cushion UCAP is to sort the hours of each season. So in this idea, we have 2 seasons per year, on peak and off peak, or summer and non-summer, and look at, sorted by this value for each hour, the tightest 20% of hours, so the hours with the lowest value. We talked a little bit about this as well. The bottom line here is how we're envisioning this could work with those kind of ratios we talked about in the ambient derates conversation. We would retain the net qualifying capacity value in our kind of NQC structure, and that would be consisted of a DQC, which would be the current definition of NQC, so qualifying capacity, derated by deliverability, and then multiplied by a UCAP factor produced in a way that I'm going to discuss here. So there, we've received a little bit of helpful feedback on the value of this approach. It's similar to how UCAP factors are applied in other markets, but we retain our NQC as a defined term, and then introduce this new DQC, which might end up looking in the context of the ambient derates accounting to also include this ambient derate accounting methodology in that DQC term. So a quick run through, and we run through this, I think, about a year ago, actually, about the supply cushion method. So we divide the past some number of years, perhaps 3, into 2 seasons, peak and non-peak. We identify those hours in each season that have the tightest supply cushion by this definition, based on some percentage of the hours. And then for each resource, individually, we determine their forced outage rate during those tightest hours. So when Perry was talking about E4D, the E4 is this, and the D is the hours that we look at, essentially. That may be a little bit of an oversimplification, but that's effectively the case. And then lastly, we got a lot of feedback in November about, if a resource performs major maintenance and has some expectation of improved performance, how do we incorporate that into the incentive element of resource-specific UCAP? So in this proposal, the way to do that is to weight the most recent year more heavily so that rapid shifts in forced outage rates would flow through to the UCAP factor quickly. So that if you did perform those maintenance upgrades and you effectively were able to have a lower forced outage rate, that would show up quickly if you had a heavy weight on that most recent year, and then each successive year were weighted less and less. So I have the natures of work discussion. I'm not sure if we're going to have a lot of time to dive into that, but I think I would maybe go through that quickly because I don't have a lot of material on it, and then we can kind of talk about these slides from there. So we asked a little bit about nature of work in the issue paper and which outage types would be counted in a UCAP calculation for a resource and which might not be. So based on that feedback, this is sort of a potential approach that we're thinking about taking. So if you could put yourself in my shoes as an employee of CAISO, the grid operator for California, any forced or urgent outage will effectively make an RA resource unavailable to CAISO for reliability purposes. Whether or not that is outside management control, it's still on a forced outage. However, we've been talking about kind of the incentive system that's intended in a resource-specific UCAP, where you want resource owners to have an incentive to reduce their forced outage rates. So that means it may make sense to consider excluding certain outage types that might be considered outside of management control that sort of more proactive resource owners would not be able to control. And we heard feedback to that extent on the second sentence from a few stakeholders. It was the Department of Market Monitoring and PG&E. So I will also note helpful slide 34 from this morning that Sai showed about the frequency of some outage types that could be considered outside of management control. And then I just have the list of all the outage types. I don't have a judgment on which ones should or should not be excluded. Again, from the grid operator perspective, there is the thought that any of these mean that the resource might be unavailable. So with that and the supply cushion design, the additional slides that I have for the UCAP section are looking at some of the values that we ran quickly based on this design to give you a sense of class averages for different resource types in the different seasons in the past, or in 22 and 2023. So let's take a few questions. I think we can go until 3.
We have Rahul and then Perry and then Noah.
And this is Rahul with AES. If you can go to the slide with nature of work.
Yes.
If I look at unit testing, technical limitations not in market, is this slide just a placeholder, or this is the final, what we should expect in the UCAP model?
This is just a list of all the outage types. So there's no categorization here. Those 4 on the right actually do happen to be what were excluded in a proposal from years past from CAISO for based on stakeholder feedback. So take that as you will.
Thank you.
Perry?
Perry Servideo, CISA. I didn't want to jump the gun on any more slides. Have you guys taken a look at the supply cushion hours and can talk about, how many hours end up on a supply cushion hour day? What do the prices look like during those? If you're getting there, then I can hold my comment.
Let's flip to it. No. Okay. Yeah, just real quick, I have this slide. This is a sort of helpful map of the supply cushion hours from 2022 and 2023. It's very helpful, but it's a summary. So the line is just the 2 different years. So you can see that, generally across the whole year, the supply cushion hours fall in hour ending 19 to hour ending 22. In the early summer, you get fewer supply cushion hours in the early summer. I'm sorry, a little redundant there. In September of 2022, for instance, you get a supply cushion hour in almost every hour of the day on average. And so I can't speak to how, this again is a summary, so each individual day for the month, the magnitude is a little bit unclear, but we can include more details if this is helpful in this straw proposal. And then if you tighten it up, so this is at 20%, if you tighten it up, it just ends up, you lose more of the morning hours throughout the year, and you're getting more into the late summer evening hours is where the supply cushion, the last 5% hours end up. So
just a little bit help interpreting this modern art here.
Yes.
If I'm looking at, if I can kind of see different rows going from the bottom to the top,
right.
Each of these rows are an actual day, and you're just dotting where the supply cushion hours were over the course of the years. Am I reading that right?
Yes.
So if I do see dots the whole way across, that means every hour of the day or most hours of those days would have been calculated as a supply cushion hour in that year and season.
Yes.
Yeah, so each line is like as you move from the bottom to the top is a day. Okay. Did you do a similar look at the prices on these days?
I have
or
not.
Supply cushion hour prices and histogram it or something like that?
Have not, but that might be helpful, sounds like.
Yeah, okay.
Next up, we have Noah.
in a much earlier slide, slide 29, you had a bunch, sorry, did not mean to.
I won't
force
click back
you.
that far.
You had a bunch of different forced outage nature of works that listed, included, not included. Can you sort of talk through, and I understand the slide before this with sort of just mainly all the nature of works that's within OMS. So, but you're seeking for feedback. Why why don't we go back to the use the list that you already have in 29 to be as a beginning point, as a starting point rather than this. It seems like you already have made some determinations. Can you walk me through sort of where we got lost between 29 and here?
So yes, earlier this morning, I mentioned kind of which natures of work were included in the modeling for the forced outage rates, and we touched a little bit on the justification there. So I think at a high level, and so I'll let you kind of speak to that if you'd like to clarify, but at a high level, there may be a difference because of that incentive mechanism where with the resource-specific UCAP, if a plant owner has ways to minimize forced outage rates that are inside management control, if you will, that is part of the intent of the design of a resource-specific UCAP. But again, we're looking, like you said, for feedback on kind of what that might look like. So, Sai, did you want to add anything on the modeling? Bucketing?
That's I think you're right on point, Ansel, and that was the intent too. So we want to keep the natures of work discussions separate for like modeling and UCAP and see get some stakeholder feedback. But we are open to take the feedback from either of those discussions and incorporate that into modeling. But to begin, for modeling, we are excluding certain natures of work, mainly outside of management control, and they tend to be a lot lower compared to other nature of work as shown in one of the slides.
I appreciate that. I think as a initial feedback, generally consistency was helpful in a program, and therefore, so if you're making certain assumptions within your model, it would be better to have them consistent with the UCAP methodology rather than under UCAP you would include all outages for this instance, but then you're not modeling it in the LOE study.
Thanks, so I've noted your comment.
Next up, we have Eric, then Adeline, then Chris, and then Doug.
Eric Little from Cal CCA. What capability does the ISO have now, or does it need to be able to police these reasons for outages if it now becomes a UCAP issue? I know it's a violation of its tariff to lie to you, and nobody has ever done that since the ISO began operation. But realistically, what ability do you have or need?
It is a tariff requirement to correctly characterize the outage natures of work, and I can jump to Abdul here. So,
well, if we do this, then we don't need to do any policing. If we say all nature of work will apply, if you're on an outage, it's going to come to us your UCAP. We don't need to police. But if we don't, as we today we have some exemptions and all that, then we will continue what we're doing today. The monitoring that we do to some of the outages between the CAISO and DMM. And if we see suspicious behavior, we investigate it, report to DMM. DMM, if they see suspicious behavior, they report it to FERC. So the status quo will continue regardless of this. But obviously, if we move to a UCAP that doesn't have exemptions, that would make life easier for us and the generators. So I don't know. David, you have your hand on the mic. Did you want to add?
Yeah, this is David Zallo from the ISO. I guess I'd maybe put the question back to you, Eric, or maybe it's something to think about more generally is, like Abdul said, we have a current process. If there's something that looks like there's a reason to follow up, we follow up. But that is a question. If we wanted to make some greater authority in that area part of this proposal because it's necessary, people view it as necessary to make this work, that'd be interesting to hear. I don't think that's anything we'd thought of to this point. But that's sort of an inherent challenge is we have to rely on putting definitions of what this nature of work means versus that nature of work, and try to define it as clearly as possible so that it's rules are as black and white as we can make them.
Yeah, I appreciate that, David. I don't have anything specific in mind right now. It's just, it seems to me that right now these natures of work don't really do anything because of RA AIM, right? So there's not an exemption from RA AIM that I'm aware of from these. There's exemptions for other reasons.
No,
but
that's not correct. Some of the natures of work today are AIM exempt. They are, yeah. Yeah.
Okay. Okay.
Okay. I mean,
so
transmission induced is probably the most common one, but there's a few others.
Okay, well, that one's pretty easy to prove that it wasn't owned by the generator. Okay, as long as it's using the same methodology, that was really what I was looking for. Is do you need additional methodologies here to be able to deal with this, or is it just what you already have? And it sounds like it's what you already have. You just see what types of outages you're getting, you monitor those, you work with DMM. If there's an investigation needed, that's fine. If not, then it is what it is. Okay, thank you.
Next up, we have
let's run
Adeline.
through the cards that are up, and then we'll move on. How's that sound?
Very quickly, because I see again the urgent outage, and I think we haven't clarified that yet. And we have a couple of questions on that, but I understand that tomorrow we're going to talk about that.
Yes, that is right. But I did put that in there intentionally, so that's a good catch. But, looking to consider that urgent outages would also be considered in UCAP under the direction we're leaning here.
Next up, we have Chris.
Okay, a couple things. So I'll try to go quick. So first off, on things like transmission-induced outages, obviously that should not count against your UCAP. There's established precedent in other regions that outside of management control type outages do not count against their UCAP. So you have FERC precedent to look at. I would not propose to do anything different than what you have in your tariff already for RAIM exemptions as a starting point. And then you could talk more about, why you would change it to count against the UCAP. I mean, that just seems to be pretty straightforward in our opinion. So that would be kind of my feedback of these natures of work. Then in general, just on the, supply cushion outages, I think, I would suggest taking a look at RAP and how they've focused on, let me back up. First off, the E4D concept, I think, is being confused a little bit here. It doesn't have to be as complicated as rerunning the entire model. I think that CISA has some good proposals within the PUC process that I've talked with Perry about a lot, but, you could use DEBs or other things instead of, rerunning the entire market to actually see if there was a, need for the unit or not. So we would prefer that CISA take a harder look at doing something like that rather than impose this 20% supply cushion, because it just doesn't actually reflect the impact on reliability. It's more of a, okay, we're just going to pick a number out of thin air that, seems to apply similarly to the amount that RAIM availability assessment hours apply, but it could apply during any hours, which really doesn't make very much sense when you think about there's additional supply that could be available that's not shown for RA, but that doesn't mean that the supply cushion is really a critical hour. Like you compare that to RAP, where they look at critical hours, and those are established based on what is the LOLE. You guys are going to do a bunch of LOLE modeling. You could look at the hours that are the critical hours in every month and apply it there. You don't need to apply this blanket 20% supply cushion hours. This goes way back to when I was at CAISO, and we proposed it because it was basically the easiest thing to propose, not the right thing to propose. So thank you.
Next up, we have Doug.
Yeah, Doug Carpa, Peninsula Clean Energy. Kind of a newbie modeling question, really. To what extent do these really vary by hour and conditions? A lot of these seem to me like they'd be pretty random in time. And that's just because I know nothing really about how this works. So that's question number one. And then I guess the second question is in the ELCC modeling and the LOLE modeling, does the outage rate vary by time or by some kind of variable, either by hour or by temperature or by whatever? And if so, by what variable does it vary? And if the answer to those is it doesn't vary all that much, then maybe we just take all hours, because a bigger sample size is generally preferable to a smaller one, which is,
Mark and Sai, do you guys have any thoughts on the, so you're asking on the second question, it was,
In the model,
yes.
is it just like, is the outage rate like it's just 5% across all hours, or is it like the outage rate is a function of temperature, hour, variable?
So this side. So are you talking about just the ambient day rate outages or forced outages? Because we separated them both.
Oh, yeah. I guess ambient's clearly related to temperature, so I guess it's everything else.
So for everything else, it is based on a single rate, but we do have like a stochastic profile for each individual resource, which is based on that rate. So for each resource, we will have 500 8760 profiles. Basically, the binary variables are 1 or 0, so based on that rate.
Okay, so it's modeled as if the forced outage rate, carving out ambient, is time invariant. But here we're going to select some hours over others. And I don't know what the real world is for like an actual generator, how much they actually vary by hour. And you can maybe control it, or like, hey, we're going to have this, thing, this rod, we're going to make it break 3 hours later, not now.
To clarify that, when you said it's a binary variable, that's per hour or per day?
That's per hour.
Okay, so
Yeah,
it is
so
it is time specific in the profile in the model. Yeah.
It's time specific for how we model it, and we put it in there, but it's a random number that's randomly assigned. So it's completely stochastic, completely random. We just define a profile from the completely random that we feed into it.
But it's not like 3% at 2 a.m. and 7% at 7 a.m. Like, that's what I mean by time variable. It doesn't vary by hour.
I mean, technically we could do that, but that would be a lot of effort, and we wouldn't necessarily have enough data to make those numbers justifiable.
Right.
How far back do you have to go and get enough data?
Where I was coming from with the question is, it really is the selection of the 20% of hours, whether it's the 20% loss of load hours, the 20% supply cushion hours. It's sort of implicitly you're selecting those because they are more important or have a different outage rate than the other hours. But in the model, they don't. They have the same outage rate. And do with that as you will.
We have Brian and then Stephen, and then we should probably continue on in the interest of time.
Yeah, Ansel, Brian Thaker with Middle River. Your modern art picture, could we go back to that real quick?
Gladly.
Surratt could not have done better, but is that available on the deck? I didn't see it.
We will re-upload it. You're correct. It's not in, I don't think it's in the current posted version. So
thank you.
Yeah.
Stephen, and then
I should say there's no reason we can't provide the specific, like a table of the actual hours, and instead of a visual representation. So I'll take that back to the team.
One question, if you go back to the next, that other one with this one. These are forced outages based on the ISO definition, right? So that's anything less than a week. It's not like the CAD's definition for forced outage, right?
Yeah, these are just all the nature of work types that we have. The forced versus planned is a parallel kind of thing. When you're submitting a planned outage or forced outage, you select the appropriate nature of work that you're reporting. The planned or forced is what applies to the timeline that you mentioned, 7 days or more in the submission, and obviously the status of the outage. If it's imminent, of the resources out of is tripped already, then that's a forced. Anything planned, then that's a planned outage.
And I should say, Steve, we're not, under this proposed approach, it does not include planned outages because, under today's practices, we're able to, planned outages are submitted and can be denied as a part of our study process. So this is only looking at forced. Oh, quick question.
This is Rahul with AES. Do we have time?
Yes.
Okay. So two things. If you go back to the art, I'm sure maybe others understood it really well, and I'm still
Let me give it
scratching my head. How do we have supply cushion hours, an hour ending 1, 23, 24, and I'm sure there is a justified reason based on the methodology.
Yeah.
But methodology does not make sense if we are seeing so many, and that goes back to Chris's point of, you know, which hour should you really pick?
Yeah.
So whatever is the best way for us to give feedback, let me know, and
Okay.
That's my feedback on the specific approach. And if you go back to the nature of work, some of these are already RAIM exempt.
Yes.
So I'm trying to figure out, is this the time to give a huge pushback, or what is the purpose of including this in this slide when, you know, some of us who are operating generators are like, is this a paradigm shift?
Yeah.
Or this is just, we are brainstorming here?
Yeah.
What is the?
I would say tomorrow the UCAP and incentive crossover discussion will cover a little bit of that, kind of the philosophy of how we're thinking about everything fitting together. You know, we heard a lot of feedback that people, stakeholders across the spectrum, supported essentially removing RAIM if UCAP were to be implemented. So in some ways, this could be a replacement mechanism for the same purposes, but as you'll hear from Anya tomorrow, we're still considering a performance or a more focused mechanism to look at kind of extremely tight conditions. So
are we saying UCAP implementation plus a performance incentive? Because I'm very skeptical of different. There is a paradigm where you just have UCAP,
right?
Whereas you have UCAP plus performance incentives.
Yes.
And it can go like, there are many different ways to think about those. So if you can get guidance on, you know, what are we going to see in proposals, that would be helpful.
Okay. Yeah, and I understand that, you know, the ability to comment on this UCAP presentation is limited without the proposed RAIM reforms or potential proposals. So just noted. Yeah. Okay. I think it's time for a quick break.
Yeah, we can probably take like a 5-minute break.
Let's do 3:20. How's that sound?
3:20.
Okay.
Hi, everyone. Welcome back. We're going to be going through a series of stakeholder presentations next. First up is the joint LSC presentation from Cal CCA, SCE, 6 cities, and PG&E. So I'll welcome up Adeline Lasource.
Hello, everyone. Let's move on with the first slide. So a couple of background on this slide. So I'm presenting on behalf of joint LSCs from KCCA, SCE, 6 cities, and PG&E. So we have been discussing a couple of proposals that were in the CAISO issue paper, mostly the outage definition, plan outage substitution, but we will present that tomorrow. And today, the UCAP design, some implementation question as well, and potential impacts on the RAIM. So you will see it's very short presentation. We don't have it's not advocating for a position. It's mostly like brainstorming and some questions that we believe should be addressed within this stakeholder meeting to move forward and start having like better design definition or at least answer to those questions. So the first slide is basically, and we have been extensively talking about that earlier, so I will go very fast on that, was just recapping the CAISO problem statement and potential CAISO's option for consideration, which are like implementing UCAP and potentially revising RAIM. So starting from the problem statement and option for consideration, I think there are like already a couple of high-level principles we agreed on what UCAP methodology should achieve or follow. So we have been already talking a lot about the CPUC and CAISO alignment, but also pointing out the last bullet, the need to keep some discretion for LRS to implement the QC methodology that they want, because according to CAISO tariff, it's one of their responsibility for LRAs. We have been also talking earlier this morning that there is definitely a need to look at the UCAP implementation in tandem with some PRM adjustments. If now you really embed the forced outage in the QC methodology, it should not be reflected in the PRM. I think from the discussion we had this morning, everybody really agree on that. And then the next step is also like, okay, if we have UCAP, we will also change the way we assess the performance, and there might be also different requirements in terms of availability incentive mechanism. Resource-specific level, also something that on high level everybody agreed on, and using as far as possible public data to be able also to calculate your own QC. And timing, we have not been discussing timing yet for implementation, but that could also should be discussed and considered. So that's lead me to the last slide we have. So in the middle, we started with an image, a graph that Kaizo put one of the slide last year, where you really see that the forced outages are really at the heart of the problem, and there are different way of addressing that. Right now, the forced outage are on average represented in the PRM, and what we are discussing right now here is okay, what if we embed the forced outage into the QC? Do we still need the last branch, which is the RAIN, the penalty for not being available? So starting from this box, there are a couple of boxes popping up on this slide, and obviously the first one is the outage definition. We have been discussing about that. There are a couple of outages definition differences between GEDAS, NER-GEDAS and the Kaizo OMS. Maybe the most problematic definition that we should reconsider or discuss is the fact that for Kaizo, every maintenance that are submitted 7 days or prior to an outage is considered as a forced outage, which is not the case with GEDAS. So it seems now they're maybe more, consensus that we should use OMS, but there are still a lot of discussion that should apply. We just discussed that on the slide Ansel was showing us earlier on the nature of work that should or should not be considered to derate the QC value for the UCAP calculation purpose. The second box and set of questions we have is related to the resources. We talked already about that this morning. There are a couple of QC methodology, ELCC or exceedance that already are basically a bit performance-based qualifying capacity methodology. So I think we acknowledge that the UCAP implementation is obviously depending on your QC methodology. The third box is, okay, if we agree about that, is then for resources that do not have the ELCC or exceedance methodology, how we do calculate or evaluate the performance. So we talked about that a bit earlier. Most of the other ISOs and RTO, they use the EFORD methodology equivalent. So it seems for Kaizo, there are a couple of issues calculating that, mostly for storage, as you explained this just earlier. There was this proposal to use the supply quotient, and yeah, maybe here there might be further discussion. Should we use because finally we use a mix of both. I tend to agree with what Perry was saying. So yeah, that's definitely maybe require more investigation. There were also maybe some risk around you won't have any indication of the supply quotient before the end of the year, right? The Kaizo won't be, you won't be able to calculate the supply quotient in advance. So then the question related to that is more would then the UCAP apply to the resource even if the resource was not shown as array? should there be like some exemption there? So that is a couple of questions we had with no real answer. Then you can also think that, okay, it's a resources that is on forced outage. Forced outage is something that you do not necessarily have control on, so maybe it doesn't make sense to have exemption. But still, some question we were not like, we didn't really have a consensus, or we're seeing like different way of addressing that. Yeah, we talk also about how many years we should look back. Kaizo is proposing 3 years. I think the CPUC, they're also on 3 years, but with different weight per year. You have also different approach, like RUP, they look at the 5 past 6 years, but they get rid of the worst years, so they do 5 of the best 5 of the 6 years. So maybe something that would be also interesting to discuss. And the box number 4, it's obviously the link to RAIN. We agree that RAIN is not really intended, working as intended. Is it because there are too many exemptions? Is it because the hours where RAIN is assessed is not working well? Couple of issues. But having the UCAP in mind, we were like trying to think of like what would be the mechanism or penalties associated with the UCAP implementation, if any. Should it be based like on a critical hours with Kaizo? And I think it's also going back to the most of our obligation we had, discussion we had earlier. If you have your most of our obligation in terms of ICAP, but you have your RA requirements in terms of UCAP, with the Kaizo like kind of look at the ICAP most of our obligation versus the UCAP requirement, RA requirement. So that was something that was coming up from this in the discussion, but we're not really sure how it will work. And the second issue also related to that is, what if you have a very terrible forced outage, an outage that's like that will take the resources out for a long time? It's a bit unclear if there is a process to convert a forced outage to a planned outage. Will there be like some process to cure in case you see like an outage will be like in too long out? So I don't know if you have think about that. And I think it's also going back to the box number 3, where we say like, oh, if the resources is not shown, should we still like calculate the UCAP value? So a couple of uncertainty and open questions around here. Box number 5, it's related to the PRM. I think we all agree that if the forced outage is embedded into the counting rules, there should be some revision on the PRM and the level. So you have been proposing a couple of options this morning. If it's ELCC, maybe you will be doing a PRM calculation for these specific QC calculation rules. But for the resources with no ELCC or exceedance methodology, there might be another PRM applied, but because now I understand that UCAP should also apply to all resources that do not have like a performance-based QC. And so yeah, a couple of still open questions around that. And then in terms of implementation, so we just discussed that earlier. So the Kaizo tariff differ to the LRAs to establish the QC, but it seems that there is a section in the RA, in the section dedicated to RA that is currently not in use, where Kaizo may have the authority to reduce the QC based on performance. So that's something we were also not so sure how it could basically apply to all LRAs or a subset of LRAs. And then we go back to this idea that to have maybe like 2 different PRMs based on the LRA implementation, one for UCAP, one without UCAP. And in terms of implementation, I think as far as possible, we should try to avoid to have different, the QC having different meaning among different LRAs. That was also like extensively discussed earlier. So hopefully we are addressing that and going in the right direction. So that was an overview of all the design and implementation question we had, and moving forward, we should have potentially answer to all of that. Thank you.
Thank you. It looks like we do have a hand raised. Rahul, do you have your hand raised, or is it okay? Okay, yeah.
Carrie Bentley with the Western Power Trading Forum. Oh, see Mike Wu. No. Carrie Bentley with Western Power Trading Forum. Can you go back to your principles slide? I thought this was really helpful to frame it this way. I was wondering whether you guys had agreement in your group about the intent of UCAP in that is it trying to better predict future availability of a resource or resources, or is it trying to serve as a mechanism, an incentive mechanism or a mechanism to punish, quote unquote, resources that are taking large outages? Whether there is consensus among you on that.
So it's a good question. I don't want to speak for everyone. I think the beginning of the discussion is that we agree that they should be, resources should have the right incentive to be available. So I would say it's more like to be available, but in a way it's also based on past performance. So that's why also I think the discussion we had on the most of our obligation earlier is also like a good way of saying like, okay, you need to be available. So we will require you to be that your ICAP, your most of obligation will be at your ICAP value, but your RA requirements will be set on your UCAP value. So here a bit the incentive that you may have, and then, okay, if you do really wrong, you will be hit for highly because of that. So I think it's really, to me, I answer to myself, it's really a mix of like availability / performance mechanism, and where we try to really accommodate both. But
Thanks, that was. Oh, can I ask a follow-up? Is that okay? Are we out of time? Sorry. Oh, waiting on this. Okay, yeah, because just to tie it into your answer, you also talked about resource specific versus group average, and I wasn't sure whether you had a position on that. And to me, if you were trying to forecast better availability, you'd say group average. If you were trying to use it as incentive, you'd say resource specific. And your answer there sounded more resource specific. So.
Yeah, Bonnie.
Next up, Bonnie, and then we'll go to Eric.
Hi, this is Bonnie Blair. I work with the Six Cities group. I'm gonna go backwards. I don't agree with your assumption, Carrie. I don't think that resource specific necessarily implies performance assessment. In fact, quite the contrary. I guess depending on the size of the fleet that you're trying to assess, it can be more accurate in terms of predictive value. But going back to your original question.
I agree with that, Bonnie. Sorry for the misunderstanding. We're on the same page. I agree with what you just said. Yeah.
Okay. Going back to your original question, I don't think we do have a consensus within the group, sponsoring the presentation at this point. And I don't think that's because we necessarily disagree. I think that question is kind of very much up in the air, and I think it's a good question for the broader stakeholder community to try to wrestle with some more, because I do think it's important if you're designing this approach to measuring resource sufficiency, and are you trying to inform resource procurement and planning? Are you trying to assess overall sufficiency and then sort of react to that? Or are you trying to incentivize certain behaviors by LRAs, by resources, and I think that program elements can be different depending on what you're trying to do. Now, maybe you're trying to do both, and that could be a useful thing to consider. And then if you're trying to do both, then, then maybe the program elements can be, I mean, hopefully they're going to be compatible and consistent and not conflict with each other. So I don't think we've wrestled with that question as a stakeholder group yet. And now I'll stop talking.
Thank you. Next up, we have Eric.
Yeah, Eric Little, Cal CCA, and not on behalf of the entire group, but I think what we've seen is that there's a couple of problems here. The first one is that RA AIM was set up as an administrative dollar amount, and it is way out of alignment with what's happening right now. If I could sell you $80 a month RA and take a $7.23 penalty for never providing anything, I'd do that every day, all year long, and I'd stop working because it would be great. I'm not saying that anybody's doing that, but I'm saying that the penalty is way out of line with what the market is currently going at. If you move to a UCAP methodology, it says the incentive is going to be whatever the price and value of RA is the next time you're able to sell it, which is going to be pretty close to what the current value of it is. The second problem I think that we see is that there's been a push for the PRM is not containing enough because the ISO sees forest outages going up and up and up. And the question is, who has the best ability to be able to effectuate changes to forest outages? And the answer is the owner of the generating resource, not the person buying it. So let's put the incentive where it belongs to make sure that there's a correct structure in place that something actually gets done rather than we just continue to increase the PRM ad nauseum.
I'm not seeing any other questions at this time. Oh, Ansel?
I just wanted to thank Adeline and the group of LSEs for putting this together and sharing these questions. This is helpful as we work towards the straw proposal. So thank you again.
Next up, we have Doug.
Yeah, Doug Carpo, Peninsula Clean Energy. So I'm like 1/26th of one part of this coalition. Tiny little piece. But it's a great question in terms of whether we aim to incentivize or to be accurate. And I think I'm not sure that those lead you to a different place. Because I think that mathematically, if you take all of the resources and you're running a series of trials, yes, no, across the entire fleet, and you take all of those trials and you come up with an estimate of the overall outage rate, I don't think that model is going to actually end up being somewhat less accurate in terms of explaining less of the variance than if you have the outage rate by resource, and then that is necessarily weighted by how much each one is on, is being shown, and then aggregate across all of those. It's like you've got the same data set and you're just slicing it in different ways, but the average of the entire data set is the average of the entire data set, whether you've got individual resources in there as an explanatory variable in your statistical model or you don't. But I do think you explain more of the variance because you're capturing the variance among generators. So I think what resource specific actually ends up with a better estimate, and it also ends up with the better incentives, I think.
Next up is a stakeholder discussion on unformed capacity from CISA. So I'll welcome up Perry Cervedia, and let me get your slides up.
I'd say the capacity is formed. This is a discussion on unforced capacity. I'm Perry Cervedio, the lead of the RA working group at CISA. And we spent the better part of the past 2 years really thinking about doing some deep thinking on UCAP. And we do have a proposal into the CPUC in their Track 3 RA proceeding right now on essentially how to do this. And I will just plug to say that a lot of our principles, I'd say most of them are aligned with what Adeline presented there. We've added, I'd say maybe a little bit more flair to it, but it's essentially the same principles. So I just wanted to say that up front. So I'll skip the principles, but really what's behind this, another way to say principles, I guess, is to get a really accurate understanding of a resource's unforced capacity whenever it's needed. Because that's really what we're seeing as critical to, say, ISO operations and reliability. And for that, we need accurate inputs if we're going to come up with accurate outputs. Another sort of way that we approach this is on the timing aspect, and to us, this matters an awful lot, and you probably lose some of the timing element if you go to just a straight E4 value, which is why we've been a big proponent of E4D. And we know the Energy Division basically has come up with an E4D that uses the supply cushion hours, and we have a different way to do E4D. So it seems like there's at least some alignment in there, and E4D works nicely with a resource-specific approach, which is, we agree, is a better way to have incentives aligned in a UCAP methodology. The last thing I'll say, this has kind of become, it goes without saying, but we really think a measured approach is warranted, and we've seen the roadmap timeline for the UCAP development here at CAISO stretching out until implementation in 2027. And we really think that there needs to be a transition period where we can see calculated UCAP values in interim years. So we figure it out now. That doesn't mean the binding first year has to be 2026. We would really be looking at maybe a binding in 2028, where we could get values calculated in 2026 and 2027 leading into it, so the market's well informed on how these resources are being derated. So what we want to really focus on today, we have a lot of elements of our proposal, but we think it's really important to talk about outages and outage definition. So for us, it's very important that it be accurate and comparable. And what do I mean by comparable? To us, it's really a relative value play here. So if you're looking at, say, a thermal resource versus an energy storage resource, under a UCAP methodology, we agree it'll be either in the PRM or on the resource, right? So under UCAP, you put the forced outage impact on the individual resource rather than boil it into the PRM. So agree on that. Now, once you've gotten there, then it becomes how do you treat these resources relative to each other? So you have to make sure that the way in which you're looking at outages across resource types is comparable, so that you're not unnecessarily hitting one resource type in a way that you wouldn't hit another resource type. And we think that's a little bit lost whenever you dive into just flat looking at the natures of work and trying to categorize based on that. And specifically for energy storage, we have been thinking about this distinguishing between a normal operating resource limitation versus an abnormal operating resource limitation. And to give an example, in general, a normal operating limitation should be incorporated into a CAISO resource model or their market design as much as possible, so that CAISO will operate it in a way that's consistent with its expected operating conditions. The second part of this is that in order to figure out what is normal operating limitation versus abnormal, we think of abnormal basically as something that causes an equipment failure causing an outage or a derate. So to us, it's really important to fine tune that definition of forced outage to be going after equipment failures, and that's consistent with the way over the past decades that NERC has done it based on their methodology. Why is this a slide about comparability between resources? Well, Energy storage resources currently today have a modeling limitation at CAISO. Now, CAISO's trying to fix it in the energy storage initiative, but they'll have limitations such as the fold back limitation, which is not in the CAISO resource model, and they're basically then forced to use a type of a forced outage to reflect this information at CAISO. Very important to reflect that information at CAISO so that CAISO can operate the resource consistent with its capabilities. And we'd never say that, we wouldn't want to inform the operators that this is the way that the resource needs to be operated and is capable of being operated in this instance right now. The problem is that that's a known limitation that could just be in the resource model. And just to give a comparative sort of example, if we think about how thermal resources, let's pick multi-stage generators. CAISO is a very advanced multi-stage generator resource model. It can model a 1x2 versus a 2x2 configuration. And CAISO knows that. It's in its model. It does its 4.5-hour look ahead, and it'll dispatch it and commit it into one of those stages. So that resource could be a 500 megawatt resource if you put it in a 2x1 configuration, but it could be a 300 megawatt resource if you put it in a 1x1. That resource doesn't have to put in an outage to be at the 300 megawatt level, and CAISO would just see that as it's available to me and there's no outage on it. But that's an example of one of these normal operating limitations that CAISO has fixed the resource model for. And we'd want that comparable treatment for the energy storage. If it's a normal operating limitation, then why do we need to have an outage on it? We shouldn't. To the extent that we do, in order for the calculation to be comparable to that thermal operating in a 1x1, then we'd want that outage to not be classified as a forced outage that impacts the UCAP value. Or you do it the other way around. You start hitting all the thermals with the derate from the 2x1 to the 1x1. I can say that I'm representing CISA right now. Our other thanks, Noah. I say I much rather prefer we fix it on the energy storage side rather than open it up on the thermal side. The point is that the particulars of this outage reporting practice convey an incorrect view of the unforced capacity for an energy storage resource. Currently, our other gripe with the way that the outage data is gathered and presented today also is that if an outage is submitted less than 8 days in advance, it's just categorically classified as a forced outage. And that's a very broad definition of what a forced outage is, and it's not aligned with, well, I should say it's very loosely aligned with how the NERC would define forced outage. And I say loosely aligned because the longest delay that can happen under NERC rules is a 7 days or less delay. So I think that's kind of the history of where maybe CAISO came up with the 7-day snap the line, it's a forced outage. But there are lots of outages that can be reported 3 days prior and still be called a planned outage or a maintenance outage. And that can occur on a Friday where you can limp the resource along for the following weekend. Let's go to the next slide. So like I was just talking about, we have industry standard outage definitions, and they are focused on the need to remove a unit from service or equipment unavailability, not on things like managing a state of charge because CAISO's resource model can't manage it yet. And the words that these definitions typically use are requires immediate or delayed removal of a unit from service, derating, reporting, is typically focused on system, a component, or a piece of that equipment that became unavailable for service, causing a derate. And it usually results from an automatic control system trip or an operator-initiated manual trip of the unit in response to unit alarms. So this is what I would call kind of you can have that happen in really 3 categories, but an alarm pops up on the screen. It's a bad one. We need to trip this unit off right now, and the operator of the resource will do that. These are all forced outages. No argument there. The point is that just drawing the line at 7 days is not precise enough for this type of definition. So our recommendation is to clearly define forced outage / derate for UCAP purposes. I put here in words. Can we not talk about natures of work, not talk about, oh, the CAISO flagged it as forced, not planned, et cetera? Can we look at the outage information or not even look at the outage information? Can we just define what a forced outage is? And then in implementation, figure out how we're going to look at the outage data to see if it meets that definition. That's one of the biggest sort of takeaways that we wanted to give, and we talk about that a little bit more in our proposal over at the CPUC. The second point that I want to talk about, and we had a little bit of a discussion on it earlier, when you get into supply cushion to define the D and E4D or some other method. And we really have come to recognize that an accurate E4D would consider unit economics. And to put it bluntly, a supply cushion approach does not consider unit economics. It could, like Ansel said, nothing against CAISO or Ansel, but I mean, you have supply cushion hours at 2 a.m. You have supply cushion hours that cover 24 hours of a day. Would we really expect an energy storage resource to be providing capacity 24 hours a day? It's outside of the limitation on the resource and what it was purchased to do. So that's just one or two indications on why we would see a supply cushion approach as not quite precise enough. And so in order to get it sort of reasonably aligned with expected storage operations, we would have to look at our definition of service hours. And the question here, what is a service hour? It's those in which a resource would have received a dispatch, or I should say service hours are those in which a resource did receive a dispatch. So if it's typically always, this comes about because the energy storage resources are typically always kind of synchronized to the grid and available if needed. But you wouldn't want to say that they are, say 24/7 availability because you really only need them in the hours that they would be economic to use. So the expectation though is they're able to operate if they're needed in those hours. So the question to us really becomes, would you, if they were on forced outage, would you have operated them in those hours? And that gets to the last kind of bullet on this slide. Would the resource have received a dispatch if it were not on a forced outage? We'd say if not, it caused no harm to system reliability, penalties not warranted under a UCAP type approach. It's all about getting to an accurate and comparable UCAP value across resource classes. One note here, I don't know if I had a...
You have a couple questions, first from Eric and then Noah.
Sure.
Okay, Eric.
Sorry, Eric, I can't see you behind this huge monitor over here.
That's all right. I picked the wrong spot. This is the seat I get to the baseball games as well. Just a question on your last bullet. What exactly does that mean? If I did the price cap and didn't get dispatched, it doesn't mean I didn't cause harm to the system. I simply made sure that it was withheld from the system by bidding a price well above its marginal cost.
You mean if I were on forced outage?
Well, you're saying if it wouldn't have been dispatched,
right?
So I can prevent a resource from being dispatched by bidding the price cap.
You're not bidding at all during a forced outage.
I know, but what you're asking is, would it have been dispatched, right?
If I were not on forced outage, would I have been dispatched? So there's one way to kind of get at that answer could be to think about looking at the P node price versus the DEB of the resource. Then I can start to, or you run the complicated counterfactual market to see if I would have been dispatched or not.
Okay.
So
you're comparing to DEB.
Yeah.
Okay.
We think an easy place to start is to start thinking about keeping with resource specificity, keeping with unit economics. You can compare a DEB to a P node price.
Okay, thank you.
Yeah. We don't have it on the slide here, but that is essentially what's in our proposal.
Next up, you have a question from Stephen.
Hello.
You talk about
Hey.
Keen from
Do we have multiple Stevens?
Well, I'm in the midst, I'm still on a web conference that's supposed to be over like in a minute, but I could call you back as soon as it's over.
Bonnie, we can hear you.
Hi,
Bonnie Blair, we can hear you.
Can we please mute Bonnie?
Sorry, Steve, go ahead.
Yeah, I was worried my voice had changed. With this, when you're talking about the resource having received a dispatch, are you considering dispatch up and down?
You
Or, I
could,
mean,
so that's,
charging and discharging?
yep, yeah. There's a couple different ways you could do it. This is one of the complications that we want to talk about on Wednesday also. It gets really complicated for a single workshop to figure out, right? And there's also different outage types and different outages in different portions of the resource that could factor in as well.
Go, Chris.
Yeah, sorry, just to respond to that too. I think, the idea of flex RA complicates this, right? If you are thinking how is your UCAP reflected as flex RA, that's a whole other discussion. So in that sense, I would say maybe you would look at the charging, but if you're talking about just your standard system or generic RA here, it should only be on the discharging side when you have an award to discharge.
I'm not sure I agree with that because storage is different than most other resources, and if a storage is providing RA, if they can't charge, then likely they're not going to be able to discharge later. I mean, you're right, there's the flex RA component that they can't adjust, up and down. But I think also, if they're on outage during that afternoon period, like from 11 to 4, that's going to make a problem for them when it comes to be later.
It's not. It's reflected in the outage that happens later because it has SOC unavailability. So I disagree. I'm sorry. It's if you actually ran that through, if you weren't able to charge up your SOC because of your charging restriction during the day, then later you would not be able to offer, and you'd have to put in an outage that right now CAISO says you have to put in as plant trouble as an outage when you run out of your SOC. So it would be reflected appropriately on the discharge side.
Let me just try to get a clarifying question in on. So I just want to make sure I'm thinking about your question right. So you're saying if I have a resource that on a day, let's say I hit my forced outage at 1600, presumably, if it's a day in which I projected higher prices in the evening, I would have been charging earlier in the day. Those charging hours fall into the service hours because I was not on forced outage. Then what happens midday is I move into a situation which now I'm not available. It's in these hours now that we would say, okay, would the CAISO have discharged me? And that's where we need to look at this, the thought of would I have gotten that dispatch? And that can be based, like I said, based on P-node price and Deb or some easier comparison than a full counterfactual. To your example is what if I were on outage all day? And then the question becomes, should I have, and tell me if I'm thinking about this the right way, should I have received a discharge or a charging, say 4.7 hours of charging from noon to 5 p.m. and then also receive the discharge? I think it comes back to, would I have got the discharge in the first place? And then maybe there I could see taking it to the point of, okay, yeah, I would have gotten the discharge later in the day, which means I would have had to have charged to provide that. But there's got to be that limit on, that would be the expected cycle that I'm supposed to provide for RA purposes. Seeing supply cushion hours as 20 hours in the day, you're not expecting the storage resource to be charging and discharging for all 20 hours in this day. So there'd have to be some kind of limitation, whether it's in this approach or the supply cushion approach, to limit it to whatever one cycle on the resource.
Last hand I'm seeing before we start wrapping up is Doug.
Yeah, thank you for all this, and this is good food for thought. As I think about this question of like, oh, it only counts if you are actually dispatched, part of me comes back to the nature of resource adequacy as an option. And so what you're contracting for as a generator is not necessarily to dispatch, it's to be available to dispatch. And so really the question for an RA, or for CAISO, I would think is, are the resources that, it's not that I did need them, it's that I might have needed them. Were they there if I had needed them? And whether you're dispatched or not isn't really material to that analysis. I don't know what reaction you have to that. But.
Yeah, that goes kind of against what I'm saying on this slide, because when you look at the purpose of E4D, aside from doing it through a demand or supply cushion based approach, you really are trying to figure out, was that specific resource in demand in that time? So you could be in the late afternoon, and it could be super thin supply cushion hour, but it's the spring and hydro from the Pacific Northwest is screaming, and we got 14 gigawatts of imports and prices are $3. Yeah. Do I really need the energy storage resource there? It's like, no, it would not have gotten a dispatch. CAISO didn't actually need it. It wasn't in demand.
Yeah, I guess sort of the way I've been thinking about it is like those contracts, like we do those contracts like a year ahead or multiple years ahead, right? Or the month ahead. And so like if I'm showing something for, let's say it's a little further on, I'm showing it for 2026, September, I don't know what like on that day, what it's going to be. But the thing I'm paying money for is that you're there for that whole period. And I mean, it's kind of no skin off my nose, right? It's really CAISO that when the rubber meets the road. So, I mean, it is. I shouldn't really say that, but it's like ultimately at the end of the day, the lights staying on. If they don't stay on, that like CAISO's most, squarely in the hot seat there. And so there's a little bit of, I guess this is a question for the CAISO staff of like, how comfortable are you with the idea that resources that are contracting to be available but then aren't needed don't have an obligation? I don't know.
Just to clarify, we're not saying they don't have the obligation. It'll just be to impact their UCAP accreditation, their going forward UCAP accreditation value. They still have the must offer, and et cetera, yeah.
I'm seeing Rahul and then Noah.
Noah Tom from Middleware Power. Have you thought about, as we go into the future, you have resources that will most likely have lower and lower capacity factors throughout the year as we continue to green the grid, right? And in that case, the amount, the times in which they are expected to be discharged, or not discharged, but just generate power may get lower and lower, and therefore it causes other aspects to maybe significantly put this forming into an extreme case where you get resources that have 0% availability because of the lower capacity factors.
Under a UCAP approach, or I could see the saturation under an ELCC type approach. I'm trying to understand your example better, though. The hours in which you would evaluate the D in the E4D, you're saying may shrink down, right?
Basically.
And then what are you saying that would cause? You're still highlighting the hours in which the resource was on forced outage and would have been needed by CAISO. It's still the same. You're trying to get at the same.
I think, essentially, if currently you have resources that are maybe 10% capacity factor, in the future they go down to 5%. So you're significantly reducing the amount of the E4D calculation that they would be applicable for. Then, essentially it's the question of what Carrie always asks, is past performance a good predictor of the future availability, and whether or not those 5% ranges or whatever is a really good predictor of 8760 for the following year.
I'm going to go out on a limb and say once we're in that annual sort of time frame, it's a pretty good, as good as any other way that you can come up with what's the value of this thing next year. You're talking, I think, more about like this long-term effect, which would then be picked up in an annual process eventually.
In the interest of time, we'll just take these two final questions. I see Stephen and then Adeline.
Rahul.
And Rahul.
Yeah, go ahead, Rahul.
So, maybe, Perry, I'm thinking through and I'll try to oversimplify what I'm seeing here. If I think of storage and economics, the simple product is TB4, right? Storage wants to charge during the lowest price and discharge during the highest price. If you just pick that for 1 year, you just pick last 1 year and look for those which have the highest price and just look at those intervals in which what was the performance. So if we go back to your last slide, is the idea that in some days in which there is really no opportunity for storage to make money, then we shouldn't consider those hours and its impact on UCAP in future years. Is that the roundabout way of thinking? Let's assume
If there would happen to be that hour where I'm on forced outage, but I would not have received a dispatch, then it shouldn't count. That's the thought. But again, you can get into how you calculate that to Eric's point.
But Perry, isn't that not because of the economics? It's because of the reliability that's inferred by the economics of needing that unit?
Yeah.
Thank you.
Thanks, Chris.
Adeline? Oh, no questions? All right. Not seeing any other hands raised then. Perry, did you have any? Stephen, did you want to add anything? Okay.
It's the last slide. That's my last pitch here.
Great. We'll turn it back over to Ansel then.
Thank you,
Thank
Perry,
you.
for sharing your presentation and these takeaways, and for a great discussion from the stakeholders. But really appreciate everyone's engagement. This has been extremely helpful to get additional feedback and further questions that you'd like more detail on in the straw proposal. So thank you everyone for a great day, and I'll hand it to Christina to close us out. It is the 25th right now, the comment deadline. So
yes,
we'll take extension. Okay.
I don't know. Are you?
Okay.
Yeah, I know, but PUC is March.
So we have this comment deadline currently. We'll get back to you on whether that date is finalized. But for any additional input, CAISO staff is also available for meetings and individual stakeholders. We will reconvene this discussion tomorrow morning for tracks 2 and 3, and more detail on straw proposal and workshop timelines will be discussed tomorrow. Thank you so much. With that, we'd like to thank you so much for joining today's discussion. As a reminder, this meeting was recorded for informational and convenience purposes only. The video file will be posted on the initiative webpage. Thank you, and we hope you have a wonderful rest of your day.
This event has concluded. Thank you for using event services. You may now disconnect.